start. So good afternoon, everyone, and welcome to the training and crash course in Python 3, ASE, and LAMMPS. To start with, everybody is requested for a prayer through a multimedia presentation.
Dear God, thank you for the opportunity to meet together. Please help us to come together to make this institution reflect your kingdom. Breathe life into our ideas and decisions. Help us build a team that has love and respect at its heart. Give us the strength to continue working for your kingdom in this time of pandemic. Lord, come give us the inspiration to be the best we can be. May we be a shining example of your goodness and truth within, wherever we are. Inspire our thoughts, discussions, and ideas, and continue to remind us that all that we do here today, all that we accomplish, is for the pursuit of truth for the greater glory of you. We ask these things in your name. Amen.
Okay, so hello everyone and good afternoon. I am very glad that we had this activity, the training and crash course on Python 3, ASE and LAMMPS, wherein the main goal of this activity is for the students, mainly for the BSc students to widen your knowledge about, especially about computer simulations. So, I hope this will not be a hard topic for you, and I think it will not be because you already had your ITE 111, if I'm not mistaken, which is about computer programming. Okay? So anyway, the speaker will guide us uh, for every task that will be given to us, para ma-solve nato ang mga kinahanglan project. Anyway, we have here the third year BSc students. I haven't seen fourth year students. And only third year students, no? We also have the faculty of the physics department, Sir Oxteros, Sir Demarcos, Ma'am Gladys, Ma'am Escobar, and Sir Apas. And probably, apas lang siguro ang uban na wala pa naka-join. So there will also be some students of Sir Vergara from the graduate school department. Okay. So in this training, this will be a 4-day training, which is all about Python 3, Atomic Simulation Environment, or ASE, and large-scale atomic molecular massively parallel simulator, or LAMMPS. So if there is also time, then probably molecular construction software such as Avogadro and Vesta may also be discussed in this course. So the training is also designed for 4 non-consecutive days to give us ample time to solve some problems physically or only. Okay, so in behalf of the Department of Physics, I welcome you all in this training, and hopefully we will finish this course until the 4th day. Good afternoon, everyone.
Okay, thank you, Ma'am, just for your opening remarks. So, At this juncture, I will introduce to you our speaker. So our speaker is a graduate of Bachelor of Science in Physics at Caraga State University and has his undergraduate in University of the Philippines, Diliman, Quezon City. He had presented several researches and published several researches and is a freelance programmer. Okay. I welcome Mr. Joseph
Can everyone hear me? Dungog
Yes,
ba ko?
yes. Yes, yes.
Okay. And I originally planned to have this informal. So would it be okay if we're mixing languages, English, Tagalog, Bisaya?
Yes, sir.
Okay lang, okay lang. Okay.
Sure.
First of all, I'd like to acknowledge then some of the people here who I haven't met. Primarily the faculties ng si Sir Ruel Apas and what's the other one? Si Ma'am Mariel Escobar. I don't think I met them before pa during my time in CSU. And also, because I have latency issues with my video, I won't be showing a video na lang. Instead, I'm going to be showing my screen. And as long as you can hear me, I'm going to discuss what I do in the screen, and then we can all work from there. Okay. If you have trouble with audio, in case na suddenly dili ko madungog, please say something sa chat so that I could backtrack and maybe I could repeat some things na nawala ang audio. Okay. So if so far there are no problems, I'll start my presentation. So first, let's go to this one. Wait. I think it's better if I just show my entire screen. Okay, so can everyone see my screen now? Can someone answer? Isang tao lang.
Yes, John.
Okay. So I'll start here with my presentation. So this is all done in the virtue of computational material science. So what is computational material science? So it's the modeling and simulation of whatever phenomena, physical or chemical or mechanical or otherwise, that are happening in materials. And through computational material science, we are able to discover new materials. We are able to discover or predict changes in materials when adjustments or modifications are made. Okay? So, for example, sa mga advices ni Ma'am Jessa, so bullet number 3, this is what we're doing right now. We're trying to see what happens to the certain material properties of certain derivatives of silicene if there are defects. So, for example, mawadan og isa ka atom, mawadan og duha ka atom, or suddenly there are impurities on the surface. So, although these things can be explored using experimental means, and traditionally speaking, material scientists are experimentalists, and most of their work, when they want to know what happens to a material, if you perturb it or if you change something in it, the de facto is to perform an experiment. However, there are physical systems that are difficult or expensive to reproduce in a laboratory. And for example, there will be times when it's very hard to create surface doping because, for example, chemical vapor deposition methods are very erratic, and if you want to have precise surface absorption, then you will have to use laser-based methods like pulsed laser deposition. That's very expensive. In fact, I think here in the Philippines there are only three universities who have PLD. So if we want to explore what happens to materials and we don't have the necessary equipment to perform experiments, a very cost-effective way of exploring is by simulations. As a matter of fact, I also know some material science groups, especially in NIP, where simulations are already part of their proposal. So before the students are allowed to perform experiments, for example, synthesis, characterization is not really a problem. It's more on the synthesis because you're going to use raw materials na ginastosan ng university, and some of those reagents are or blenders are very expensive, and it's important that you're able to a proof of concept first. So the proof of concept is usually modeling and simulation. Okay, so what are the components of computational studies? Basically, when we say computational material science, that stemmed from theory. Originally, the first uh, people who formulated molecular dynamics were theoretical physicists. So initially, it was just really a matter of doing the theory. For example, solving the Schrodinger equation or solving Newton's equations of motion. The problem is, in material science, you don't have just one particle. You have a collection of atoms, and in the case of electronic properties, you have a collection of electrons. So theory will not be enough to just to create the necessary simulation. But you can always just deal with the most simplified versions of physical systems and then attack it from a purely theoretical perspective. Actually, up until now, this is still a very effective method. A lot of people in Italy at the ICTP or at the Institute for Basic Sciences in South Korea and other places, they were able to discover certain properties of two-dimensional materials using a purely theoretical method, using field theory. So, aside from theory, you can also check experimental data. So this is where the computational material science starts to become an art, because you need to compromise how much of the theory do you need to accept and how much leeway do you have to give for it to fit with experimental data. And then recently, I think post 2015, with the rise of big data, so artificial intelligence methods, basically these are methods that use neural networks. These methods were originally applied for targeted marketing strategies on the internet. A lot of freelance programmers know how to use AI tools to create business models. But material scientists, physicists, and scientists in general, they all realized that it doesn't matter what kind of data you're handling, the tools from artificial intelligence could work as long as you have a sufficient amount of data. So now that we are actually in the shifting from the third or fourth paradigm, I'll be showing a slide about that later, where we are now no longer just relying on theory and experiment, and we're using pattern recognition codes or machine learning from the paradigm of AI. Okay, so there are different ways of combining these three components to produce a computational research. Okay, so you can have something that's purely theoretical. So that's first principle calculations. By default, density functional theory is included in first principle calculations. Pero chemists will get angry with this because they believe that DFT is not a first principle calculation because you're doing approximations to it. And then there are also Monte Carlo methods. Monte Carlo methods are basically stochastic models of what happens in materials. And then you have classical molecular dynamics, uh, which is what is offered in LAMMPS. And I believe that before my arrival in CSU, there were already a couple of students who were able to perform thesis research on classical molecular dynamics. So far, as far as I know, the only person who has done a first principle calculation or a DFT simulation is myself. And hopefully, if we get hardware, if we get the things that are limiting us right now computationally, then we could work on any of these methods and explore larger systems. Now, the thing with using theory is this uses numerical analysis. So we're putting the heavy burden on the computer. And this can become computationally expensive. So there are also methods that combine theory with experimental data. And if we do that, we obtain what are known as semi-empirical methods. So, pag semi-empirical methods, basically that's just a theory and then you have corrections based on experimental data. So this is entering the realm of phenomenology. So for example, you have density functional theory calculation, but you're going to put Hubbard corrections. So Hubbard corrections are from magnetism studies. There's already a vast amount of data for this, for different conductors, semiconductors, and superconductors. So you add those corrections para mas maging accurate yung calculations mo using density functional theory, or could also have classical molecular dynamics with highly corrected potentials. Okay, so you can neglect theory altogether and you just rely on your experimental data and then use the tools from artificial intelligence or machine learning in order to form what is known as materials informatics. Okay, so the problem here is just in the same way as in financial modeling and in business modeling, AI became useful just after that after 2015. So basically, 2015 is the year when people claim that we already reached the point of big data. There's already so much data about everyone that's just lying around somewhere on the web, but that is not true for materials. Recently, Berkeley has made the materials API project, so that they have uploaded a very very big database of almost every type of information from every performed experiment in material science. I'm going to show you the website later on, but basically using that data and using machine learning analysis, so you can have what is known as materials informatics. So for example, you can predict the band structure. For example, if you have the band structure of graphene, then you can predict the band structure of graphene with one atom missing using existing experimental data sets and pattern recognition codes from AI. Or better than pattern recognition, you have neural networks. And then finally, we can combine theory, experimental data, and AI. This is also still a branch of materials informatics. But basically what happens here is you have a theory and then you have a machine learned exchange correlation functional, density functional theory. Sa classical molecular dynamics, you can have pseudo potentials that are also machine learned. Meaning the existing pseudo potentials, they are compared to, for example, kung pseudo potentials for graphene. For example, if you have a Tirsoft, for example, sa LAMMPS, if there's an existing Tirsoft potential for graphene, then you can compare that with a very, very large data set on information on graphene and create the necessary corrections for that potential. And then you use that potential in your Newton's equations of motion so that you can have a more accurate results with your classical MD simulations. The latest build for LAMMPS, I think the 2020 or better the 2021 installation of LAMMPS already allows for machine learning corrected potentials. Okay. So this is just a diagram of where we are right now. So for the past few decades, we have been in the third paradigm, computational science using DFT, molecular dynamics, kinetic Monte Carlo. The fourth paradigm, or big data, uses all of the underlined methods, AI, statistical learning. This is basically naive-based learning, pattern recognition, and data mining. All of these are actually available as packages in Python. So right now, here in the Philippines, we have a few people who are already at the fourth paradigm. But actually, even in UP, many of them are still at the third paradigm. They're still trying to explore how much computing power we are going to need to jump into the fourth. So for now, all of our studies are done under the third paradigm, which are using large scale simulators. Like for DFT, the most famous are Quantum Espresso and Gaussian. For LAMMPS, we have for molecular dynamics, we have LAMMPS and so forth. Okay, so this is just a diagram showing the synergy between theory, experiment, third paradigm computational method, that's underlined here under computational science. And then the materials informatics are here on the database ends. Okay. We're not going to deal a lot with this for now, but hopefully we could have another set of meetings for this. But we're going to deal completely inside this orange box, which is computational science. Okay, so these are just the appropriate methods compared with how large the, the size of the system is and how long do you want the simulation to go. Okay, so the time scale here, this is not the time scale of the actual computation in your computer. That just means to say, for example, 10,000 seconds. So, if, for example, if you remove one atom in graphene, what happens within 10,000 seconds? Okay, so that's what this time scale means. System size scale is, of course, it's measured in meters. So if you have something that is in the realm of nanoscience, you're dealing somewhere here between the first principle electronic structure methods, which includes DFT, and this molecular dynamics. This is actually quantum molecular dynamics. The molecular dynamics available in LAMMPS, it's categorized here in force field methods. Okay, so this is the limit. You need 10,000 to 1,000,000 atoms if you need to do LAMMPS calculations, because if you do something like just 1,000, or well, actually just in the hundreds in the force field methods, you're not going to get a very accurate simulation, because that's going to break the periodic boundary conditions. Remember, in solids, the arrangement of atoms is almost approximately regular. So the way we are able to impose that regularity is to assume that the model is big enough. Okay, so that's the same concept with sometimes when we assume that something is an infinite plane in electromagnetism. So in order to perform some physics, to use some calculation techniques, we need to make the object very large so that finite size effects are not are negligible. Okay, So it no longer assumes that it's a periodic boundary condition if you have a very, very small size of atoms. However, for first principle methods, if you're going to learn electronic properties, we need to use first principle methods. The problem here is that it's very computationally expensive. In my experience, I was dealing with 4 by 4 cell, and the mature electronic structure calculations for band structure would reach up to 3 days. And I was already working on a very powerful computer unit. So in order to break that, to simplify the computational complexity para hindi mahirapan ng computer, we need to reduce the number of atoms that we deal with here in first principle calculations. Okay. So, what we're going to be doing is classical molecular dynamics, because so far in our capacities, in the capacities of our computers and what we are able to afford, this one is less computationally demanding. So we need lesser computing power, we need lesser memory. But there's also a disadvantage. There are a lot of interesting properties in nanomaterials that we cannot explore, especially those that involve electrons. So almost everything important in nanoelectronics, we can't access that using classical molecular dynamics. But we can predict the mechanical properties. We can know how elastic the material is. We can predict its strength. We can also make predictions on the thermal properties, assuming that the Born approximation holds, which means that's assuming that the energies from the core ions, from the atoms themselves, are much more important than from the electrons, from the sea of electrons in the solid state material. So we can do classical molecular dynamics. We can program everything from the ground up. Okay, we can forget about LAMMPS. We can do everything either in C, C++, or we can make our own programs in Python. But the problem is that's going to take a lot of time, and there's a lot of software issues that we will have to deal with. So why not just use a package that is already proven to be effective? So that is the large-scale atomic molecular massively parallel simulator, or what is known as LAMMPS. So in LAMMPS, we deal with Newton's equations of motion. This is a very, very large system of differential equations, because every atom in your material or the system that you wish to simulate, you're going to run the Newton's equations of motions for each of those particles. At the end of the simulation, you're going to have a data which contains the entire tracking of the positions and velocities of all of those particles. And then you can just perform ensemble calculations, calculations from statistical mechanics to obtain thermodynamic and vibrational properties, like, for example, thermal conductivity, or we can also check the vibrational density of states, and we can check other bulk properties using the resulting, it's called a data dump in LAMMPS. Okay, so aside from using LAMMPS, we also need to know some programming languages in scientific computing. In your ITE classes, I assume that you've been taught either C or C++, but the first ever scientific computing language was Fortran. And as a matter of fact, Fortran is still being used by developers in scientific computing up until now. If I'm not mistaken, even in Giant4 and in Junt4 and in Quantum Espresso, there are still some developers who use Fortran. But when the package is finished, they have a different language that's used. And if you want to do the calculations on a web-based approach, then you can use Java. Then there's also Python. So a lot of people in scientific computing are already using Python. And there's this new programming language that came out, I think 2016 or 2017, which is called Julia. So Julia is in a lot of ways similar to Python, and it is assumed to be the successor of Python in the coming years. But of all these, aside from these programming languages, by the way, these programming languages, the 6 logos that you see on your screen, these are called general purpose programming languages. That means pwede natin silang gamitin for scientific computing, but they are also used as programming languages for other purposes, for creating databases, for programming machines. I don't know about Julia, but I'm sure Fortran, C, C++, and Python, they're being used to make machine programming or create programs in robotics. And Java, of course, everything in our phones run on Java. Everything on the internet runs on Java. Every app that we use, if there's a graphic user interface, chances are that is running on Java. But aside from these general purpose programming languages, there are also other programming languages or software which are used in scientific computing. So everybody is familiar with Mathematica. I think people from engineering are very, very familiar with MATLAB. And then there's MapleSoft. So a lot of people from math departments all over the country, they use Maple in conjunction with Mathematica. And then there's also an open source version of Mathematica and Maple, which is known as Sage. Personally, if I'm just going to do some numerical analysis from a straight up theory perspective, I'm going to use Mathematica because Mathematica also has a lot of packages for physics. As a matter of fact, the leading analytical package for astronomy and general relativity can be found in Mathematica. It's called Exact, and a lot of my peers have been using this, and well, not just in GR, but in most simulations in the theoretical context. If you're going to build the code implementation of your equations from scratch, a lot of them use Mathematica. The problem here is that these are not meant for general purpose programming. So in an academic setting, if we want to teach our students a programming language, we should teach them a programming language that's useful for scientific computing, pero useful din for general purpose programming. Because it doesn't mean to say that you're a physics major, doesn't mean to say that you're going to end up doing physics until the end of your life. Okay? To widen the options or the horizons of our students, it's better if the programming language that they know can make them do what is necessary in physics, but also can make them do a lot of other exciting stuff. So we stick with general purpose programming languages, and in particular, we stick with Python. Okay. So there's a lot of complaint I get in CSU when I mention Python, although right now, sa CCIS, this is already becoming a very, very popular language, especially sa mga nagdi-data science. So, if you have been taught C or C++, why am I insisting in teaching you Python and building a new framework of programming for you? Why not just continue on with your C and C++ experience? Well, first of all, to the third years who are joining this meeting, a lot of your classes back then have been cut short. Am I right? So, your education in C or C++ programming is, I'm assuming it's not complete yet. So, it's not much of a change if I teach you Python programming right now. Okay? But that's just the practical aspect para sa atin in the context of the CSU physics community. Aside from that, there are many more arguments for using Python for scientific computing. Okay, so why Python? Number one, it's easy to write code and it performs well. Considering that uh, the standalone Python is actually slower than C or C++, but uh, whatever amounts to that slowness, you can speed it up using numbus or using this package known as Numpy. Okay, so it's easy to write code, a very, very easy programming language to understand. If you read a Python script, it's as if you're reading uh, a scratch paper full of math calculations. It's also as if it's also called an idiomatic language in the sense that it's like writing sentences. Also, it boasts a very large ecosystem of packages and modules for scientific computing and data science. And finally, I only see this in Python. Python is the only language where I see that you could collect all of your problem solving tools, even those which are not written in Python, and then work work with all of it using a Python environment. Okay, if you do C++, then those software packages that are written in C++, you could operate in them. But if you're going to switch to a different solver which uses Fortran, then magsiswitch ka pa sa Fortran. In Python, even if the native code of other solvers like LAMMPS, like Quantum Espresso, GPO, Orca, even if those softwares or packages are not written in Python, somebody made a way so that you could call these things into Python as if they are Python libraries. Okay, I'll talk about that more in detail, but for now, just look at the different logos that are in this slide. So you have SciPy, Matplotlib, Pandas is very much used in data science. Scikit-learn has a lot of uh, methodologies for not just for data science but for treating experimental data sets. Phoenix is a system for finite element numerical methods, and then there's a bunch of other packages like TensorFlow or PyTorch, AstroPy. I also put here PyMatGen and MatMiner. Right now, these are in the early stages of development, but these are the future of computational material science. MatMiner, especially, MatMiner can crawl throughout all of the existing online databases for material science and get you what you need. Gusto mo ng cellular structure for graphene, you want cellular structure for silicene, and you're too lazy to build a program to create that, you can just mine the web using MatMiner and look for your needed cell structure. Okay, and there are a bunch of other Python packages that are meant for physics that are not here on the screen. Basically, you can think about every niche or every subfield in physics or every area na maisip natin. Even in GR, there's a GraviPy, although not a lot of people use it. But chances are, whatever the niche or the subfield, there is already a Python package that has been written for it and is being used by a research group somewhere. And with how the Python community works, all of this can be found for free online. As a matter of fact, Python has a system called the pip, and in the pip, you can find almost every existing Python package, and you can easily install that to your computer. Okay, whether you would be able to use the package in your computer, that will depend now on how much computing power does your processor have, or how much how much memory does your random access memory have. But nevertheless, there will always be a package that has been used. to treat data in every field of physics. Okay, so let's go back to what I mentioned earlier, that it's a wonderful toolkit to integrate problem-solving tools into one container. Because our end goal here, why we're holding these Saturday meetings, is because uh, we want to model some materials in the computer and find useful physics about those materials. So in Python, they have something called the atomic simulation environment. Uh, what is the atomic simulation environment? So basically, it is a toolkit which collects all of the existing solvers that are being used in computational material science. So for example, if you can see on the screen, baka malabo sa iba, pero uh, there are a lot of existing softwares here which can be collected by the atomic simulation environment. Okay, so LAMMPS is one of those packages, and so is Quantum Espresso, VASP. This is actually amazing because VASP is not an open source software. This is proprietary. You have to buy this. But if you're able to install VASP in your computer, you can call it in Python using the atomic simulation environment. Okay, why is this important? Why is it important to have a toolkit that can call all of these calculators when you can just operate on these calculators separately? Well, the thing is, for example, I want to carry out simulations that are quantum mechanical in nature on hydrogenated silicene. So that's a nanomaterial. I could use either Quantum Espresso or GPO, or if I have the money and I can buy VASP, I could use VASP, or I could use AbInit. But then I want to see what happens with its mechanical properties. So pag mechanical properties, you need a larger sample. You need a sample of 10,000 atoms. Eh di na pwedeng gamitin si Quantum Espresso or si GPO or any of the first principle calculation codes. So whatever data you generate here, especially the cell structure, you can then just import LAMMPS also within your Python script so that whenever the appropriate solver is LAMMPS, pwede na to gamiton si LAMMPS. When the appropriate solver is something from DFT, then we have more choices. We have Quantum Espresso, we can use Gaussian. There are others here with no pictures, but basically if it's listed here, then you can use it as a calculator within Python as long as you have the atomic simulation environment. So to be able to use the atomic simulation environment, what's important now is we should know how to program with Python. So where do we do Python programming? Now, if you have received the instructions for the day one package and you were able to install Anaconda, it would be really, really nice if you could follow through all of the training using Anaconda. The problem with Anaconda is it's very, very heavyweight. It's a very, very heavy installation and it's going to use up a lot of computing power in your computer because it also has a lot of functionalities. So you can use the notebook interface, or you have the scientific Python development environment or Spider. You can do a lot of other things, a lot of analysis in Anaconda, but in exchange, you will have to sacrifice a lot of computing power in your laptop or in your computer. Okay? So to simplify the problem, at least para lang sa training natin, we can use what is known as the Colab. So the Google Collaboratory is something provided as a service by Google. So we can write and execute Python in our browser without having to install anything. And we can use GPU accelerated hardware. Okay, and then of course, well, as is with everything in Google, it becomes easier to share. Also, you have up to 24 gigabytes of RAM usable even in the free version. So I'm not sure how much RAM in you have in your laptop, but I'm pretty sure that most home appliance stores, if you bought your laptop from typical computer stores, you're not going to have this big of a RAM. And especially when dealing with quantum mechanical codes, uh, RAM is a really, really very big requirement. Okay? But the really nice thing about Colab, it's not just about the RAM, it's not just about the GPU acceleration. The best thing about it is that although you're programming, which means basically you are computing something, the computing is not done by your computer. It is done by the Google Cloud. Okay, of course, may mga setbacks lang dito. There's a limit to how much storage, how much data you can store. So maybe after running one simulation, you have to download all of that data and erase it from your Google Drive, for example. Okay. Now, also the other setback with the Google Colab or Google Cloud Computing is that the only programming languages available as of now are Python or R. That's because Colab was not really meant for computational material science, but for data science. So since these are the two most popular languages in data science, so that's what they uh, uploaded in or installed in Colab. Okay. So that's the end of the introduction, and now just for some housekeeping. So these are basically the goals of the online workshop. So we're going to go through programming as if we don't know programming yet. And then by day 2, we're going to crash course everything, one semester's worth of computational physics by introducing scientific computing fundamentals. Okay? And then by day 3, we're going to move to the atomic simulation environment. We're going to learn the ASE, even without using LAMMPS in ASE, you can perform molecular dynamics in ASE. It has its own molecular dynamics calculator, so we will also explore that. And then by day 4 or onwards, or even when this training ends, we can keep on corresponding. We can build solver packages or import these packages, LAMMPS, QE, GPO, or any other library. We upload it to AE and then use it as if we would any module in Python. Okay, so that are our goal. Those are our goals for our workshop or online workshop. Basically, this is an informal workshop. And just some guidelines on how to approach this workshop. Okay, number 1, I really plan this to become an information overload. Maybe not for this day, but especially day 2. Day 2 is going to be an information overload. But it's okay to not get it all at once. It's okay not to understand all at once. Okay, that's why I specifically requested to have the meetings 1 week apart, so that in between those meetings, you can scan through the notebooks. Okay, the notebooks are really, I tried my best to make them as detailed or as self-learnable as possible. But in case you're not able to understand some things in the notebook, even after the meeting and even after going through it yourself, you can talk to me anytime. So I set up a Discord server for all of us. The server is not on right now because I have to dedicate some power to the Google Meet. But after this session, I'm going to turn it on again, and you can start joining the Discord server. So there we can talk anytime. If you need troubleshooting, if you need help in how to install certain packages in your computer, if you need to troubleshoot your codes, or if you want to talk about the physics of computational material science, then you can contact me using that server. Every now and then, I'm also going to be dropping the solutions to the exercises on that Discord server. I think this is quicker than emailing everyone who participate. Okay. So this is the rationale of day one. So notebook, there are 3 notebooks for day one. So the first notebook will just be a run through of everything that we are supposed to know from programming. And then we're just going to put some emphasis on string slicing operations because this is something that's kind of unique to Python. And it's an important concept when we read in data dumps from LAMMPS or input files from LAMMPS into our Python code. Notebook 2 will be doing some simple math calculations using the math and the Numpy module. And then for notebook 3 we will be going through some basic plotting tools or mechanisms in Python. Okay, I was supposed to discuss interatomic potentials today, but I figured it would be better to discuss the Lennard-Jones potential, the Tirsoff, Stillinger-Weber potentials when we reach numerical differentiation and numerical differential equations. So for now, our only task will be the particles approaching equilibrium. Okay, so this is very similar with equilibrium molecular dynamics, although this is a very simple version. Walang differential equations. It's just a matter of statistical mechanics. Okay, so just again how to approach this workshop. I'm going to go over the notebooks really as quick as possible because they are quite long. And anyway, the notebooks are meant to be self-contained and self-paced. And then for everyone, it's up to you if you want to do the exercises or not, except for the advices of Ma'am Jessa, because I designed those exercises specifically for them because those are things that they will have to be able to do to perform the calculations that they need for their thesis. Okay, again, it's just a 1 meeting per week, but the learning goes on throughout the entire week, and you can contact me anytime and we can talk about the exercises or whatever your questions are. Of course, I won't be able to guarantee that I can answer all of your questions, but it's better that we discuss it rather than you're trying to figure things out all on your own. Okay, so that's going to be not the end of this meeting. Di lagi na ako ma. Were everyone able to see the presentation? Sorry, I didn't
Yes.
notice someone.
Yes.
Okay
Okay na,
naman.
okay na.
Yes, yeah.
Okay. Okay. So, I'm going to stop the screen share because now I'm going to show you my entire screen. Okay? So, I'll stop this for now. And then, I'm going to present my entire screen. Okay. So, if we're going to do Python, normally, if you have installed Anaconda, exit na ito. If you installed Anaconda, then you would get Spider. So you can do programming in Spider just in a very similar way that you would do in C or C++. Sa C or C++, ang pinakasikat na IDE is code blocks. So don't find the codes here. I'm just showing this environment. So this is one way of doing programming. Most of lessons in or introductory classes in Python will show you that programming has to be done in this kind of development environment. However, if you have installed Python in your in your computer, or specifically if you have made the Anaconda installation, then you would have something called the Jupyter Notebook. Okay. So, kunwari, na-install nyo yung Anaconda. So, you're going to find something here, an Anaconda 364-bit. And then there's going to be a Jupyter Notebook icon. Okay. I'm not going to click on this because this is meant for another workload of mine. Okay, this is the Jupyter Notebook that I dedicated for this seminars. So I'm just going to press this and then wait for it to appear here. So if you installed Jupyter, you're supposed to get something like this. This is the dashboard of your uh, Jupyter Notebook. Okay. Now, if you receive the folder that contains the materials for day 1, then dapat meron na kayong day 1 folder. Okay? So if I open the day 1 folder, it looks like this. There are a bunch of files which has a .ipynb extension. So those are the programming notebooks. And then you just have data files which are in the form of text files. Okay. So if you receive the RAR file, just bring the RAR file to your desktop, uncompress it, and then you'd get the day 1 folder. Now let's go to the Jupyter dashboard. Okay? If you launch Jupyter, it's going to use your default browser. So kung ang default browser niyo ay Mozilla Firefox, or if you're using Brave, whatever your default browser is, doon bubukas ang Jupyter Notebook. Okay? Once you get that, look here at the, wait, I'm going to zoom in. Go to the New tab, and then click New Folder. Okay, so this is the new folder. I'm going to go back here. I'm just going to rename this folder as day 1 folder. Okay, so you can follow along if para to sa mga nakapag-install ng Anaconda installation. Okay, so you can click on the day 1 folder and then you can upload. Sa upload, okay, you go to stop and then to day 1 and then copy everything except the checkpoints. Do not copy the checkpoints. On hindsight, I should have deleted this when I sent this to you. And in any case, highlight niyan lahat, and then you can open that like this. Okay? So just click upload. It's going to upload really, really quick. And then, for example, if you want to start with day 1.1, so click on day 1.1, it's going to give you this. Okay. So if you look at it, it's structured like a book or like a notebook. For those who are familiar with Mathematica, you can also do the same thing with Mathematica. Actually, I have a Mathematica version of my day 1 and day 2 lectures. I'm also going to send it to those who prefer doing things in Mathematica. However, if you want to do computational material science, hindi pwede Mathematica. But for day 1 and day 2, this is going to be generic na computational physics. Okay, so this is how it is structured. And for example, if I want to add a new cell, I could press this button, insert cell. So here it made a new cell, and I could choose whether this cell could be a cell for making codes or markdown. Pag markdown, that means you're writing text, and kung code, edi it's going to make it a coding cell. Pag coding cell, di ata mag-program. Pag markdown, those are notes that you will have to write. Okay? I hope the advisees are paying attention Because from now on until you finish your thesis, every time you have questions for me, I want you to write a Jupyter notebook for it. Okay? So diri mo mangutana og kuya, wala ko kasabot. Okay? Okay? For example, the good thing about this is in Markdown we can also write in LaTeX or in MathJack. So for example, I want to write a derivative is equal to g of x, and then I'll just press shift enter, so it's going to give me something like this. Okay, so for example, if someone would ask how to solve this differential equation, shift enter, so it's going to appear like this. So any questions that you throw upon me, it's better if we communicate by writing your questions like this. Number one, it helps you learn LaTeX. Number two, it helps you learn how to write scientific papers. Okay. As a matter of fact, there are some computational physics workshops. I mean, formally organized workshops that use Jupyter notebooks for their presentations na rin. Okay. If I want to turn this into a coding cell, I want to do programming, then I just type here code. Kung gusto na ko siya mo og text, so markdown. Code for programming. Okay, I'm going to delete this cell since I don't need it for now. Now, what if you're not able to install Anaconda? Okay, if you are not able to install Anaconda, open a Google Chrome browser and then just Google Colab. Okay. So if you go to Google Colab, actually a faster way would be to type colab.research.google.com. Okay? So pwede lang i-click na ninyo ang Colab. Something like this is going to appear. Okay, I'm going to cancel this. So if this is the account name, for example, I have a lot of accounts. So everything that you do here will be saved to the Google Drive linked to this account. Okay. Now, I'm going to use a different account. Sige na nga, I'll use this one. Okay. So I'll just say cancel. So now I'm signed in using this particular email. Now, go to File. Ito mo sa File, click Upload Notebook, and then you can just choose the file. Okay, so if you want to upload, go to your Day 1 folder, and then if you want to upload Day 1.1, then you just click on Day 1.1, and then it's going to upload. Okay, so it's going to appear like this. So there's not a lot of differences in using Jupyter or Google Colab because actually this environment was just copied by Google, pero this is just actually a Jupyter notebook. Okay, you want to add text. If you want to add text, you press text. So this is text. You can add equations in a similar fashion. So I want to put backslash pi squared. Let's say. Okay, so you can typeset things like this. Press shift enter, so it's going to put out an equation like that. Okay, so this is why I like programming on a notebook, because you can annotate every step that you make. If you want to add a code, edi ito lang. So you look for this magic line that comes out, and then if you want to add text, you add text. If you add code, then add code. Okay. So that's all there is to it. I'm not going to require you to install Jupyter, but if you have installed Jupyter, then this is how it's going to look like. If you want to use Google Colab, then this is what it's going to look like. Now, to be able to run programs in Google Colab, go over this part that says connect, and click connect. When you click connect, it's going to allocate resources for you. It's going to allocate a storage drive, and it's also going to allocate a disk. Okay. So right now, let's try zooming in. Nope, it doesn't work that way. I'm not sure if you could see it, but right now, if I hover my mouse to this portion, it's going to show me how much RAM has been allocated to me and how much hard disk. So by default, any free user can use 108 gigabytes of hard disk and around 12 gigabytes of RAM. We can push this to 24 gigabytes of RAM, but we don't need it for now sa mga applications na to. But just for you to know that it's possible, if you want to explore that option later on, we can talk about it outside of these meetings. If you go to this arrow, you could get additional connection options. So you connect to local runtime. Kung naatay supercomputer sa CSU, then you can connect to a local computer. And we can also enable, this has already been enabled for GPU acceleration. So anyway, let's start with Python programming. So as is with everything, with every other programming languages, the first thing you do is print hello world. Okay? So if you in a coding cell, pindot lang mo og shift enter. Okay? And then it's going to print out this statement. Okay? Sa mga naka-Anaconda, okay, I'll run it also. So this is out like that. Basically, pag mag-print ka, you just put parentheses, and then if you're going to print a word or a sentence, ibutang nimo sa sulod sa quotation marks. If you're going to print a number, you don't need to put anything. If you're going to print the value of a variable, you don't need to put quotation marks. Everything in quotation marks are interpreted as strings. Okay, for the rest of the discussion, I'm going to stick with the Google Colab version. Okay. So these are just different ways of printing hello world. Pag na-backslash n, that's going to create a new line. And then, if you notice here, if you have 3 quotes, so it's going to print in a paragraph form. These are 3 single quotes. So these are just different ways of printing a statement. Not really important for scientific computing, but it's always a standard exercise for new programmers. Okay, we can also do some string formatting. For example, we can make a variable, and wait, let's just zoom that in. We can make a variable. For example, ang pangalan sa variable kay name, and then I'm going to put inside there a string called Computational Material Science with Python. Okay, so I can print it like this using %s, meaning percent is like a pointer. Kung kadumdum pa mo sa inyong C++, so there are pointers, and then s meaning it's going to point to whatever string value is stored in the variable called name. So kung ang nakastore sa variable kay integer, ang inyong ibutang diri kay b. Kung ang nakastore sa variable kay float, so you're going to put here f. Or since it's a string, so you just use s. Okay? So this is just another way of doing something similar. Here, this is an empty container, and what it's going to do is, since this entire thing is a string, si kaning command nga format, bisag unsa ang sulod aning variable nga name, iyang i-format into a string and put it in the place of the curly brackets. Okay. So let's run that. And you get three different ways of saying the same thing. Okay? So the value that we assigned to the variable called name is a string. Pero we can also assign different values. So pwede integer. Pag integer, walay decimal point, and then obviously, mathematically speaking, it's an integer. Floating points have decimal points. Complex numbers use j. J ang square root of -1. Nganong dili I? Because I is commonly used as an iteration index in Python. And then Boolean variable, you can put here true. You can also put here false. But for now, let's just put it as true. Okay. Once I run this coding cell, so in Google Colab, you can run by clicking the play button or shift enter. Kung naa mo sa Jupyter Notebook, everything is shift enter. Okay, shift enter yung tanan. Okay. So, walay result. That's because what we did here is we defined a variable called integer and then di-store na to dito ang value nga 1. Okay? So we have here floating point, di-store na to ang 3.14. Okay. So we can find out, I'm going to add text. We can find out the data type contained in a variable using type. Okay. For example, dire, i-try nato sa complex number. So it's going to give the class complex. Okay, pwede ra pod nga dili ka mo gamit sa print function, i-diretso ra nimo type ang type na complex. Igawas din niya ang complex number. For example, let's say floating point. If you press shift enter, it's going to give us float. That's because ang naka-store is 3.14. Kung buo na ko ni, himo na ko ni 34, so that's now an integer. Bisan pag floating point ang pangalan sa variable, the type is going to be, dapat ako linggiran. The type is now going to be int. Okay? That's because ang naka-store na sa iya kay an integer. So if I put 34.5 and run this again, so mo adjust po siya accordingly. So it's going to become float. Okay. So you can use Python as a calculator. This is pretty standard. This is just the same as what you would do in C++. So if you use plus, so it's going to give the sum. Minus gives the difference. This one will this is the only thing that's important here, because this is something that's not in. This is actually a weird thing about Python, because we are used to using A caret B to say, example, if you wanted to say A raised to the B, ba? So, ang naanda na to kay kanin siya nga symbol, caret. Okay? Pero in Python, if you're going to perform a mathematical operation where you raise A to the power of B, so you have to use double asterisk. Okay? So this is a common mistake with starters in Python, labi na kung gikan o lain na programming language. Since in most programming languages, this is how we do it. But here in Python, for some reason, this is how it does exponents. Okay, so I think that was pretty straightforward. Now, by the way, in Google Code, if the notebook is very, very long, it's going to give you something like this. Okay? May mga 13 cells hidden. Diri kay nakadire-diretso lang siya kung naka sa Jupyter. Sa Google Colab, it tries to hide cells so that you can see the overall extent of your notebook. Okay? So if you want to reveal everything that has been hidden, so you just press this and it's going to show everything. If you have used Mathematica notebooks, it works the same way. Okay, so let's start with something that's more important for us. It's how do we store values, how do we store data, and how do we manipulate values. So there are different kinds of containers in Python. There are tuples, there are lists, and then if you use Numpy, then there are also arrays. Okay, so tuples are sequence of values. Pwede mixed type. So for example, kani strings ni siya tanan, and then kani siya tanan kay mga integer, which are immutable. When we say immutable, di na nato na ma-change. So kung na-declare na nato, for example, si tuple 1, na-declare na nato nga mo ni si tuple 1, example, let's press play. Okay? Di na nato na ma-change. Dili na ta makaingon nga tuple 1 equals a to h 1 to 11. Okay? Mo na gina siya ang tuple 1 until the end of everything. Unless imo na siyang i-delete and then i-redefine. Okay, so how do we access the elements of a tuple? Okay? So we use the indices starting from 0. So standard man siguro nino sa mga, especially with the faculty nga niagi na og programming. If you have any container, arrays man na siya, or tuples or lists, the first one is always index or position 0. For example, diri tuple 1 0. So that's going to give us A. So this is 0 and then this is 1. This is 2, 3, 4 and so on. Okay. So for example, just as another demonstration, if we want tuple 1, if we want to know what's at the fourth position. So ang fourth position is number 3. Kung unsa ang ikaupat nga element, number 3 siya. Kaya nagsugod man og ihap sa 0. Okay? So we play this and it's going to give us D. Okay? Now a very useful trick, for example, we don't want to access all of the data here. We just want to access a few. Okay? We can use index slicing. So in index slicing, if we say 4, 9, it's going to start at the 5th element and everything before the 10th. Remember, kung 9 ang number, that will be the 10th element. Kung 4th, that will be the 5th. Inclusive, exclusive, meaning, ang number diri sa wala, sa left, that will be included sa count, pero that will be everything until before sa 9. Okay. So, let me just show this. So, igawas niya ang E, F, G, H. Okay, note nga tuple 1, this is A, B, C, D up to H and 1 to 10. Just as a simpler demonstration of this, if I want tuple 1, I want from second element and up to before index 4. So, pag 4, this will be the 5th element. Okay, so this means from the second element up until from the second element and so on, excluding the 4 plus 1 is 5, 5th element. Okay, it's going to show B, C, D. So the second element is B, the 5th element is E. So pag ngayon kag 1, 4, so from the second element, which is B, up to before, without including the 5th element. So it's just going to go B, C, D. Okay. And then we can also have something like this. Let's just make this a little bit smaller. Let's make this 7. So this will be from the 2 plus 1, from the third element and so on, excluding the, what's the second argument? It's 7th. The 7th element in intervals of 2. So meaning third element, fifth element, and so on. Okay? So pag ito na iwas, it's going to show C, E, G. Okay, so that's the third element in C. And then intervals of 2, so laktawan niya ni, diretso siya sa next, which is E, and then it goes to G. Okay. If you leave the first argument blank, then it's going to slice from the beginning. Okay? So it starts from the beginning up to before the 13th in intervals of 2. Okay? Kung wala po ang nasa tunga, remember ang sa tunga is munang exclusive na end. So it's going to start at the 6th in intervals of 3 up to the end. Okay? So it's going to give this set of values. When we say slicing, meaning we created a new tuple from our predefined tuple, which is tuple 1. Okay, pwede po tayo mag-count backwards. For example, if we put here negative 1, going to give us 10. Okay, so which is the last item. Okay, if we're going to put negative 2, going to give us the second to the last item. And then of course, you know already what happens if I put here negative 3. It's going to give the third to the last item. Okay, sometimes you have a very big data set and you just want the first few or the last few of that data, then the way to do it is use index slicing. Okay, so if tuples cannot be changed, meaning once they are defined, dili na nimo sila ma-change, lists naman are mutable. So lists usually, this is where you collect values. So for example, you can have nested lists. And if I want to print the nested list, just do this, and it's going to give out the nested list. When we say nested list, the elements of a list is in individually also lists. Okay? So for example, kung na kay 3x3 matrices, that's actually a collection of 3 rows. So kada row kay it's considered a list. Okay? So if we do this, 1 and then put a colon, a double colon, so it's going to give out, remember, kung 0 ni siya, that will be the first row. Kung 1, so that will be the second row. And then it's going to give all of the elements in 1. Okay? So this is number, if it's 0, kung butang na to diri 0, it's going to first give the first element of the nested list. So that's 1, 2, 3. Now if here I'm going to put 0 to 2, so this means so good sa 0, position 0, and before sa position 2, which is the third element of this sublist. So it's going to give out just 1, 2. Okay? If I change this to 2, so the third element is this list. So it's going to give us computational molecular, which is just the first and second element of the third element of the larger list. Okay? So with a list, you can also change entries or append new ones. For example, if I have a list, wait, let me delete this first. So if I to define this list, so silicene 1, 2, 3, graphene, molybdenum disulfide. and then I want to add something to the list, or I want to change something. For example, I want I want the entry at the second position, which is indexed as 1. I want to change it into the word 1. Okay? If I do that, let's print the list again. So it's going to change the second element. Okay? As simple as that. Just say, hey, look for this particular position and give it a different value. From an integer, I want it to become a string. Okay, so it's going to put out 1 like that. Okay, you cannot do this with tuples. If you try to force a tuple, it's going to give an error. So lists are mutable, meaning even if you have declared what the list is, you can still change it. So lists are usually the baskets where we put our data. Tuples, we can put in tuples the basis vectors for our calculations. Kaya ang basis vectors, for example, if you're in the spherical coordinate system, specific gid na kung unsa imong mga basis vectors. You have to protect it na in such a way nga bisag masayop ka og code, dili mabag-o tong imong basis vectors. So if you are going to define the basis vectors, for example, this is just an example, then you can use tuples. Now, if you want to generate a calculation on that spherical coordinate system, then the data that you'll be able to collect from your calculation, you can put that in lists. If you want to append or add more data to a list, so you can just use append. Okay, so for example, I want to add a sublist with thermal and conductivity. So I'll just use append, and then it's going to store that here. Part na siya karon sa my list. Okay. I could also delete contents from the list. So if I say 1, so that's the second element, up to the fourth. So from the second, third, and fourth. Okay. If I delete this, what happened was, si number 2, number 3, number 4, nawala siya sa list. Okay? So I omitted some data to produce this new list. Okay? If we want to remove permanently something from our list or from our data set, then you just use remove. Okay. So one more function which works on any kind of collection data type, so whether tuples, list, or dictionaries, is what we call the Len function. So Len function is going to give the length of that collection. How many elements are in that collection? Okay, so for example, my list, how many elements? There are 3. Okay, the string silicene, the string graphene, and then the sublist with thermal and conductivity. Okay, that's treated as one element of the list of my list. So kung ihapon na nimo tanan ang len, so it's going to give you 3. Okay. So there are a lot of operations on lists. I did not include everything. So one resource you can use to find out more is this one. It's called Geek for Geeks. Untana, by this point, we make it a practice that if you can't figure out something, although you can contact me, you can also try searching for it on the web. Chances are, if it's a programming question, there's somebody out there who is more than willing to answer, or the answer is already available in the web using tutorial sites or in the Stack Overflow forums. Okay, so let's go now to strings. So strings is also a way to collect data, but basically, normally what we would see as strings are words or sentences. For example, we have this string, and we try to print from the first up to position number 29. So the first 29 elements of this string is going to give you computational material science. May muna ko nig 29, So up to the 28 lang, so mawala ang letter E. Okay, so I think somebody else joined. Uh, there are more operations on strings, but basically what we have to realize is that strings work like lists. And vice versa. Kung unsay mga pwede nato buhaton sa strings, pwede nato buhaton sa lists. And basically, halos tanan mga data files ay interpreted siya as a string. Okay? Excel files, text files, CSV files, kung unsay operations available for strings, you can work it with Excel files, you can do it with text files or JSON files or CSV files or even mga data dumps like what we get in LAMMPS. Okay, you can use split. So pag split, it's going to split the data based on the separator. The separator is whatever you put inside split. So for example, split nimo siya niya empty, meaning split every time it encounters an empty space, split na niya. Okay. So for example, computational, material, science with a comma, Caraga State University. So those are all interpreted as individual elements na after using split. Okay? You can put a different character. For example, kung comma ang atong ibutang, so it's to go back to this string and look for the comma. It's going to separate based on that comma. Okay? So if we have this, then shift enter. Okay, so it divided the string according to comma separated values. This is something that's important because a lot of data in physics are usually stored as .csv files or comma separated values. For example, if you have a calculation on a wave function na 3D, so ang value at every point na xyz ay nakastore na siya as a comma separated value, xyz. So in order to access or manipulate that data, so you will have to use the function called split. More on that on our next few meetings. But for now, I just introduced that you can use split. For example, what if ang separation sa data kay colon? So colon ang atong ibutang dire. Kung comma, which is the most common, so comma. Another common pod na separation is no separation at all, which is just kumaga space lang imong gibutang. Okay, I'll just run this again for safety. Okay, so I have a string with spaces, so na space diri, na space diri. Okay. So I can split that. So here it's splitted again. Every time it sees a space, it's going to delete that and store the next value as a visual element. And then nana po space, so tanggalon niya ang space, and then the next value is stored as another element. Okay, and so on and so forth. Okay, we can also join strings with using the .join command. Okay, so let's see what happens here. Okay, so it joined out the elements of why are there spaces here. So I have a list called list of words. Now I want to join them and put a space separation. So it's going to appear like this. This is not too important for now. So the most important here is split by comma, and well, just as a demonstration of what else you can do with string. So it's going to remove the space at the beginning, at the ending. It's going to strip this of whatever is in here. For example, dili na space sa sugod o sa last. So if you use strip, so it's just going to take those spaces out. Okay. So, so far we have discussed strings, lists, and tuples. So dictionaries are just another way of collecting basta naka-define. So meaning there are keys. So for example, carbon is to graphene, silicon is to silicene, germanium is to germanine, and so forth. So if the element is carbon, and I want to print out whatever is corresponding to carbon. So I could access it as a key. Okay, so ang key is name of dictionary and then square brackets and then whatever variable ni mag-store ang mga key. So for example, kung bayluan ako ni siya og silicon, okay, so it's going to go over the list called my dictionary and look for the key which is silicon and then give out the material silicene is composed of silicon atoms. Okay. Medyo ano na to? Medyo irrelevant na to our purposes, pero this is just another operation that you can do in a dictionary. Meaning you can iterate over a dictionary. For is a loop method or an iteration method, which we will discuss more later. And then for now, we have what are called conditionals. So an important thing in every programming language is that you're able to branch out your operations. Depende sa condition. Okay? So the way it works in Python is you have an if statement, an elif statement, and well, wait lang. This is supposed to be an else. Okay, so if you saw that in your Jupyter notebooks, this should be if, elif, and else. Okay? So, for example, a equals 5. So if a is less than 5, mo niyang iyang i-print. I am in the if block. And then a is less than 5. Okay? Else if, meaning elif, kung equal siya to 5, edi everything underneath is what is going to be processed. Okay? So these are your branches, kaning if, elif, ug ang else. If this is the one that is true, then it's going to perform everything under the branch. Kung kani ang tinuod, kung dili ni siya tinuod, it's going to go here. If this is the condition that is true, so this is going to go through this branch, and if not, then it's going to go to else. Okay, let's say I'm going to change the value of a to 2. So it's going to say I am in the if block because 2 is less than 5. I put 2000. I press enter. So I am in the else block because this is not equal to 5 but this is greater than 5. Dapat guys, this is more. Okay. So the same thing holds here. And what I just want you to notice is every time there is a branch, you have to indent once. Okay? So the indication of a branch is either an if, an elif, or an else, followed by a colon. Okay? So pag naka-colon, pag mo enter ka dira, it's going to give you an indentation right away. Okay? So we can re-indent this and see what happens. Okay. Basically, that's the same thing. Right. Okay. Just make sure na it's properly indented. So Google Colab, Jupyter Notebooks, either they have different ways of indenting. The important thing to know if you are properly indented is to go to the colon. Pag abot niyo sa colon, press enter. Kung asa na siya mo linya, that's a proper indentation. Okay? If not, so actually, for example, if I want to properly indent this, then I have to bring it all the way to the colon and then press enter. Okay? That means it's properly indented. Colab is a little bit more intelligent than uh, Spider or Jupyter in that it's trying to understand what you're coding and trying to minimize your errors. Okay, that's one of the benefits of using a cloud computing machine, because the machine itself, by the way, the machine itself in Google Colab has an AI tool using TensorFlow, so it's able to optimize things for your code. It has its own intuition. Okay, so B is between 7 and 9. Then if I make this 12, okay, this is just another demo. Okay, so if you're used to C and C++, sa C or C++, you usually get an if statement, then the indicator of a branch is the curly bracket. So, pwede ka na kay curly bracket, everything under that curly bracket, mo na siya ang mo-operate pag kani nga branch. Okay? Iba nga na sa C, C++. I think even in JavaScript, that's how they make branching statements. Here, it's all about indentions. Okay? It's indented to say that everything inside this indention is part of that branch. For example, if I want to make another indention, if, for example, B is less than 7 and less than 9 and greater than 7, and then I would also like to say if B is an even number, B modulo 2 is equal to 0, then let's say print even. Okay. So what happened here? You already have a statement that's branched, and then you created a new branch, which is the new if statement. Pag enter na ako, kay nag-create siya og bago nga indention. Okay? So kaning print even, may tabo lang ni siya if this happens. Kung kani siya nga particular nga conditional. And we can nest this, pwede pa mo mag-nest o daghan kayo ng mga branches. For every time you make a branch, you have to indent. You have to indent what's after it. Okay? So these are just logical operations, meaning you can call conditionals. So, for example, let's try this exercise. Find if a given value C is less than 0, greater than 10, or in between 2. Wait, I'm not going to do this anymore, pero you can do this using the same constructs. So if, elif, else. Okay. So let's go now to something that's going to be used a lot, especially in iteration calculations, which are called loops. Okay. So there are two types of loops. I think sa lahat naman ng programming languages, you have the for, you have the while. Sa C or C++, you have other types of loops. Pero to keep it simple in Python, there's just two. Pag for, you're defining right away the range. Okay, so for example, for I in 1, 2, 3, 4, print I. So let's see what happens here. Okay, so it defined the range. Okay, I is your iteration variable, or iteration variable, and then it's going to go over this range. Okay, and then print I. Okay. So what it does is it goes through all of the members of the list and it prints the members of the list. Okay. So for example, for I in range 0, 10, 2. Okay. The command range will give you a range of numbers starting from 0 and then less than 10 in intervals of 2. Okay? Range of integer values ang ihatag ani. So let's press play and see what happens. So it gives you 0 to 468. Okay, kung mag-start kasi 0 and less than 10, then all that you're going to get are the even numbers. Okay. So pwede po natin, for example, for I in range 0, 10, and in intervals of 2, ang gusto na ko i-print is 2 raised to the power of I. So that's going to be 2 to the 0, 2 squared, 2 to the power of 4, 2 to the power of 6, 2 to the power of 8. So it's going to give something like this. Okay. So for loops are used usually in numerical integration, and we're going to be focusing more on for loops. But just to show you also what you can do with a while loop. So, for example, if I have an iteration variable, nagamit na maguna ko ang I, so I'm going to define something new. I'm going to call it 5. And then you have the iteration or the looping condition. While my iter is greater than 0. So if the value is 5, then of course it's going to be greater than 0. So this will also create an indentation or a branch. So what happens is, first it's going to print out 5 squared. Okay? And then it's going to reduce the value of my iter by 1. So una kay minus equals 1, meaning ana sa next step bawasan nimo ni siya og 1. Okay? The same ra ni siya sa my iter equals my iter minus 1. Okay? Parehas na siya. Pero just to shorten everything, you have minus my iter minus equals 1. Okay. So let's see what happens here. So you get 5 squared, 25, and then mo minus siya og 1. So ang value na karon ni my iter is 4. Is 4 greater than 0? Yes. So you're going to do this again. 4 squared, 16. My iter minus equals 1. So 4 minus 1, 3. Is 3 greater than 0? Yes. So continue pa siya. 3 squared, 4 squared, 1, until 10. Okay. Oops. Okay. So here you have list comprehensions. So list comprehensions offers a shorter way of looping without having to go through all the complications of a for loop. Okay. So for example, na ako'y list of string statements. Okay, I want to make a new list. Okay. In my new list, what I'm going to do is I'm going to take out the last 3 letters. So that's if x minus 3 is equal to in. So kung ang last 3 letters kay in, ako siyang i-append sa bago nga basket or container or list known as xanes, and then append. Okay. So kung in, ene, it's going to disregard that. Kanipod, ene, it's going to disregard all of those. And then it's going to go straight to these elements. The elements na ang last 3 are A and E. Okay? And then it's going to create a new list for that. How many lines did we use for this code? 1, 2, 3, 4, and 5. Okay. So you can just do list comprehensions. So we can make a new variable xanes2 and then create square brackets to indicate na gusto nimo maghimo og list, and then just say x for x in 2DM, meaning include here the elements of 2DM na ang last three characters are A and E. Okay? So it's also going to give us the same thing. Okay. For example, we have a range of t values. Ang range atong t values is 0 to 9 because that's what is range 10. Okay? We can create our list of values for x following this formula, 3t plus 1/2 10t squared. Wait. So if that's 1/2 times, this should be 10, then this should be 3 times t. So 3t plus 1/2 10t squared for t in the list capital T. Okay. So you get something like this. Okay. Of course, you could also just go for t in range 10 Okay? Basically, pwede na po ka oh wait, sorry. Create ka og basket or list. And then we could just say for t in range 10, we do the entire thing. So we copy this. We could say x dot i-append na to ang result of this operation. And then put x. And then you get the same thing. But here, you spent more lines than what you would in here in cell number 73. As a matter of fact, pwede pa natin siya bawasan og lines by just saying for t in range 10. Okay? You can delete this line. So now we just have two lines, which gives us the same thing. Okay? This becomes really convenient later on. Now, here we have functions. Functions are basically chunks of code. So mga dagko ni siya nga block of code that performs a particular task. Okay? So I'm not going to go over all the pros that I wrote here for sa notebooks, pero these are meant so that if you would read it by your own, you could learn this even if I'm not physically or visually teaching it. Okay? So this is how you define a function. You have the def command and then you have the name of the function. So this is how you make a function definition. Def, name of the function. Kung walay argument, so just make an empty open and close parentheses and then the ever important colon. Okay? So here, these are called doc strings. So for example, it's going to show you kung unsay ginabuhat ani nga function. Okay? For example, if the function prints hello world, then here it should say this function prints hello world. For example, we define square x. So this function has one argument. It returns one value. The square of the argument. When we say argument, mo na ang value nga ginasulod nato diri sa open and close parentheses. Okay? The value that will be returned is placed here in return x squared. Okay? Pwede na po ka maghimo og variable nga squared equals x squared and then you say return squared. Okay? That's fine, but it's a waste of coding lines. Makes it longer for the interpreter. So, ngana na lang. Pero if you have a complicated function, it's better to use namespaces or variables. Okay, so for example, we have y equals 5 and we want to print the square of y. So, we call the function just simply by writing the name of the function. It's going to give us 25. Pwede na po ninyo i-print, pero pag interactive mode, even if you just call the function, put the right argument inside, and then it's going to tell the function to do its thing, which is to return the square of the argument. Okay, if I put here 15, run that again. So that's how it works. Okay. So dito din, it's going to return two values, x squared and x cubed. If we want to unpack, then we could do this. For example, square and cube equals powers 5, meaning it's going to map the returned values of powers to the variable square and the variable cube respectively. Okay? From square and cube equals powers 5 is going to return a tuple which consists of the x squared and the x cubed. Okay, so let's press play and then let's play here. So we get 25, 125, and the tuple 25 and 125. Okay, so these are exercises or work examples. I'm not going to go through all of the exercises because it's better if you go through the trial and error process of trying to solve all of these. Pero I've also laid out how you would solve some of these problems na. Okay? So, I hope you go through this in your free time. And if there's anything you don't understand, you can message me in Telegram or in the Discord server. Okay? Again, this is optional except for the students of Ma'am Lazarte, because I really want to see if they are able to do this, then they will be able to do the more complex programming that will be needed for their work. Okay, so I just want to emphasize that one important module in prototyping, meaning prototyping in designing the codes to solve a particular problem, is the time module. So sa time module, you can measure the starting time. Start time equals time dot time, meaning pagbasa sa computer, what's the time right now? It's going to store it at start time, and then it's going to process whatever code imagibutang diri. So kung diri naghimo kag instructions to LAMMPS, nag-carry out kag simulation, i-carry out na niya, and then finally it's going to print out a statement which says how much time did you spend or did the computer spend in performing the actual task. Okay? So again, this one hindi ko na i-discuss because this is just an exercise. But there's one exercise in particular na I want to go through. Okay? Let's go over this. So palindromic numbers. So a palindromic number is a number that is horizontally symmetrical. So 121, 232, 1001, 1221. You get the idea. The first and the fourth term are the same. The second and the third term are the same, and so on. Okay? So, what is the largest palindrome made from the product of two-digit numbers? Okay? So, the first thing that we have to do, okay, wait, I'm going to write out steps for the solution. So, number one, write a function that checks palindromes. Number two, go through all the products of two-digit numbers. Okay? And then convert those products to strings and check if palindrome. So number four, if it's a palindrome, collect to a list. If not, then ignore. Okay? So obviously, what do we need here? We need conditionals. We need branching statements, if and else if. And then if we're going to go through all the products of two-digit numbers, we need a loop. Okay? So the convenient way here is to make a for loop. So I already wrote the function that will determine if a string is a palindrome. Okay? So basically, it's going to check if ang mga opposite na elements, for example, kung zero ni, so this is 0 minus 1 or negative 1, so is the first and the last element the same? If it's the same, if it's not the same, then of course, delete na siya palindrome, so it should return false. Okay? So I'm just going to press play so that the definition of this palindrome is stored in the kernel. And then here, I'm going to press palindrome. So here, I have put as a test, kaninga word, ana, mana. So if you notice, ang ana, mana, ang first o ang last, parehas, letter A. Ang second o ang second to the last, parehas. Ang third o ang third to the last, they're also the same A. And then of course, you don't have to compare anything sa middle na term. Okay. So if this is a palindrome, it's going to return true. If I change this to something that's not a palindrome, say banana, then it's going to return false. Okay, so how do we use this function now to to go through all of the two-digit numbers? Okay, so this is what I'm going to do. So let A be the two-digit numbers. Okay, so by the way, I forgot to mention anything that follows a sharp sign is a comment. Pag comment, wala na siya ginapansin sa computer. Okay, so I'm going to assign or use these iteration variables A and B. Okay, so for A in range, if it's a two-digit number, so it's from 10 to 100. Remember, walay labot ang 100 kung naka-range. Okay? So for A in range 10 to 100, okay? Now, I also need to create a loop for the second number kasi sila dapat duha two-digit numbers. Okay? So for B in range 10 to 100. Okay. Whatever I can get by multiplying A times B, this is going to become a number. My function only works for strings. So, I need to make a way para ang makuha na ko nga product so that the product that I make out of this will be converted into a string. So I'm going to say strnum. Okay, that's just the variable. And then I'm going to typecast. So str A times B. Okay. So if A and B are integers, their product is also integers. By typecasting, I'm converting the product into an integer. Okay. Now, how do I use the function? I'll say, wait, by the way, I need to palindromes. I need to make an empty basket. Okay? Because what I'm going to do is, every time I see a palindrome number, I'm going to add it to this basket. Okay? So, I now convert the product of any multiplication here into a string data or a string variable. And then I'm going to say if palindrome strnum is true, so kung true si palindrome strnum, then I will append that product A times B. Remember, ang akong i-append sa list is not the string version but the actual integer. Okay? So if the string version is a palindrome, meaning palindrome's strnum equals true, then I will append or I will add that product to this empty set. Okay? So magkakalaman lang ito pag may nakita akong palindromes from the product of two-digit numbers. Okay. And then I'm going to use something called max. Max palindromes. Okay. Max palindromes, this is going to return the biggest item or the largest value in the list. Okay, so let's try if this works. Okay, so it gives 9,009, which is, for sanity check purposes, that is the largest palindrome, which is a product of two digits. Okay, so the code goes here. You can try extending this program so that instead of the searching through the product of two-digit numbers, you will be searching through the products of two three-digit numbers. So meaning there is A ug B kay between 100 and 1,000. Okay, so I'll leave this as an exercise. Then also finally, we have made it to the end of this notebook. Okay, relax lang. If there are things na unclear, you can read over and read over and read over again in the notebook. That's why I made it a notebook, because basically, even without someone teaching, you can learn these things just by going through these notebooks. Okay, so that finishes the fundamentals of Python. So this is Python that is slower than C or C++. How do we do something faster? In order to do something faster, we have to introduce modules into Python. Okay, so in order to do that, upload ta through og notebook. So go to File, Upload Notebook, and then choose File, and then go to day 1.2. Okay, hopefully you already uploaded all of this beforehand, but if not, then you just keep on going to your folder and upload the notebooks to your Google Colab. Okay? Pwede ba magkadungan ang Python version installation like Python 3.7 and 3.9 installed in laptop? Okay. So, if you installed Python 3.7 as an individual na installation, and then mag-install kag Anaconda nga naka 3.8 or 3.9, then if you're going to do programming sa Anaconda, ang muga na kay ang 3.9. Pero if you use Python nga katong native na installation, katong dili sa Anaconda, then it's going to use 3.7. Okay, for example, 3.9 karon ang imong Anaconda. And then may gawas nga 3.11 or 3.1000 or basig 4 point na. The only thing you need to do is go to the Anaconda prompt and then just type conda dash update. If you do that, mawala ang imong 3.9 and then iyang ibaylo kung unsa ang latest nga installation. Okay, I'm sorry I did not see this earlier. Okay, nag-reply si Sir Joel. Okay, so I'll just also type it in the chat for everyone. So we can always go to the conda prompt and type conda dash update. Okay. So, kanila kung pero this will only update the Anaconda, the Python version in Anaconda. Kung gusto nimo i-change gid sa tibok computer nimo, then you will have to uninstall the first one and then install the whatever is the more later version. Okay? So, if there are if you have questions, just keep on going to the chat box and type your questions here. So I forgot to say that pala. If you have questions, just type it here, and I will just keep on going through the notebooks. Okay, so right now we're going to go to modules for calculations. There are a lot of modules, or basically, I'm showing this because if we can learn to use modules, pwede na lang din nato import si LAMMPS use via ASE na mura ra siya module sa Python. And then everything that you need to order LAMMPS to do, LAMMPS is going to do separately, but all of our orders will be done within Python. Okay? So there are many modules. The common modules for calculations are math, which is basically it's just the math library of C++. Ilang gi-hijack, himo nilang Python. Okay. Now Numpy, because it's an interpreted language, it's kind of slow. Python is slow when dealing with arrays, when dealing with matrices. Pero if you use NumPy for your calculations, bibilis din siya. It's going to become competitive with even MATLAB. Okay, so how do you import a module so that you can use it? You can use import math. Okay, I'm just going to change this here to empty. Before, Ched Kahukom asked me if pwede bang uh, I'm going to run this code first. Wait lang. So, okay, it's connecting. By the way, in order for you to run something, you need to make sure na here, na i-check box. Okay? So, dapat, sometimes magod ko naka-disconnect or connecting pa siya, diligin mo run imong program. But don't worry, Google will always accommodate you because everything you do in your programming here becomes useful data for the Google AI. That's why they're providing us the opportunity to use their cloud computer. Okay, so in order to use the functionalities of the math module, so we have to call math.factorial. Or for example, kung ato na siyang gi-aliasing, pwede ta mag-mt.factorial. So ang ihatag ani kay ang value ni 5 factorial. Okay. Now, when I first taught Python sa CompuD sa CSU, somebody asked me, why not just do this? Because Chad was already going through Stack Overflow. So why not just do this now? From math, import, star. Okay. When you say from math, import star, that means from math, import all. Okay? And then pwede na ka mag-declare ng nga factorial, let's say 6 factorial, so that's 6 times 120 or 720. This and give you something like this. Okay, so I'm going to discourage this. Highly discouraged. Because, for example, there are functions like sine, cosine nga naa sa math module naapod sa NumPy. Or, for example, if you're going to use numbers or pandas, naapod sila ilang own functionalities for calculating integrals, for calculating factorials, for calculating trigonometric functions. If you do this, maglibog karon ang computer nimo kung kinsa bay ginatawag nimo nga factorial function. Ang naa kang math, ang naa kang numpy, ang naa sa numbers, or ang naa sa scipy. So, to avoid confusion, always use the aliasing so that the computer knows where you want it to get that particular function. Okay? When the computer gets confused, it's not going to bid well for us. We're going to suffer because it's going to take it more time to complete the computations. Okay, again, while I'm discussing, just keep on typing questions, or later on at the end of the session at the Discord server, and I'll try to answer as much as I can. Pero for now, I'm going to go over all of this quickly. Okay, so pwede po ta mag-print og mga constants like pi and the Euler number, the Euler constant, and carry out calculations like this. Okay, so akong gusto pa-notice diri kay kaning cosine 90, because cosine 90, although this is a variable, we assign to it the value of cosine pi over 2. Now, cosine pi over 2, if you're still familiar with your circular functions, ang value dapat ana kay 0. Pero here, it's giving us 6 point something times 10 to the negative 17. Okay, well, specifically, kang collab. So, practically 0 man siya. So, why are there some strange numbers at the end? So, I need to copy that. It suddenly deleted it. Okay, so I'm going to copy this and put it in comment. Okay, so why did we get this 6123 sa dulo? So these are errors in machine representation. Especially if it becomes very, very small, there is a discrepancy na in handling the calculations. This is also the reason why sa computer, dili po ta magpataka-taka og assign og time step. For example, gusto nato accurate kayo tong time step. Gusto nato mag-calculate siya per 1 times 10 to the negative 1 million seconds. For example, we can't do that because we also have to be concerned with what is the smallest number that can be represented in that particular computer. And that's where floating point arithmetic errors and machine representation errors become an issue. I'm not going to discuss it further, but just always remember there is a smallest number that can be represented by your computer, as well as there is also a largest number. Those values differ per computer. Okay, if you go over this particular link, it's going to teach you how to find out what's the smallest number and the largest number that your computer can easily represent. Okay, so it's because of those machine precision limitations that you get errors like this. Okay, so just another word with the math module. If you want to carry out logarithms, sanay kasi tayo na when we say log, when we say the logarithm of 100, kung ganun lang, we expect nga ang answer kay 2. Because we expect that when we say log, it's carried out to the base 10. Pero in the computer, when it says log, that's actually a natural logarithm. Okay, a natural logarithm. Okay, and then if you want base 10, so we use the command log 10. Base 10 logarithm. Okay. So, using loops and using factorials, we can now create Taylor series approximations of certain functions. For example, ang function na to cosine x. So we have a Maclaurin series for it, and we have a Maclaurin series approximation, which basically truncates it to a certain number of terms. Okay. So for example, here, this is an infinite series representation of cosine. Pero remember, our computers do not know how to interpret infinity. Later on, there's an exercise about the Madelung constant where you will have to deal with what are you going to do with infinity. Well, the thing is, you can approximate infinity by putting a very, very large number. Okay? So, in this case, dili ra kayo large since paspas man kayo ang convergence ani nga Maclaurin series approximation. So, we can write a program where we assign the true value to be the value of cosine that is stored in the math module. And then the approximation, we create this for loop. Okay, what this for loop does is it's going to get 1 and then it's going to get pi over 4 squared over 2 factorial and add it to the series, then add this again, then add to the 4th power, and so on and so forth, depending on how many terms in the approximation do you want to use. Okay, so for example here, if this is n equals 14, una ang number of terms nga gusto nato gamiton sa approximation. So it's going to run up to the 14th. It's going to add all of the 14 terms. Okay, so what happens there is we get an approximate value from what we call cosine approx. Initially, ang value niya kay 0, and then we have this term called the nth term. So for example, ang 0th term diri kay 1. So i-add niya diha ang 1, and then i-add na po niya diha ang this term and then this term. So at every part of the loop, so first part of the loop, it's going to add 1. So the value of the cosine approx is 1. If we add the second part, then it's going to add this one, the pi over 4 squared over 2 factorial. If up to n equals 3, so i-add na po ni Mia. So that's the purpose of this loop. And then we can calculate the percent error by subtracting it from the true value, divide by the true value times 100. Basically, the normal way we calculate an error. Okay? So for example, kung n equals 1, so isa ra ka term. Let's see how much error we get. Okay, so the error is 2.1965%. Okay? If we increase the value here into 2, so the error, nag-fluctuate ang error, nag-negative siya. Okay, again, this is a problem with floating point precision. So we increased it again, n equals 3. So here our percent error is now very 0. And if we increase it further to, let's say, 14, it becomes 1.57, dili na siya dako, kay that's times 10 to the negative 14. Okay? We just got lucky here because we have a very, very fast converging series approximation. Okay, so this is how you perform numerical calculations in Python, because most of the time, even integrals are just an infinite series of sums of integrand values. So an integral runs in a very, very similar way to this. If we want to approximate something that is infinite, then we will need to put a really, really large value sa n. Okay? That's also the same reason why sa LAMMPS or sa molecular dynamic simulations, kinahanglan dako kayo para accurate ang atong approximation sa system. The system also needs to be appropriately large. So sa LAMMPS, minimum nato is in the order of 10,000. Okay? That means at that approximation, considerably sufficient na ang convergence sa atong mga calculations. Okay? We will discuss more on that later sa day 3. But for now, this is just to show na this is how a computer does calculations. Ang computers, dili na sila kantigog calculus. Dili na sila kantigog abstract ara. The only thing that a computer knows is linear algebra and arithmetic. Actually, ang linear algebra is just a very, very acrobatic way of doing arithmetic. Mo lang gina ang kaya buhaton sa computer. It's just performing complex types of or sophisticated. I shouldn't use the term complex. Sophisticated arithmetic really, really fast. Okay, that's why no matter how fast a computer is, there's still the need of a human element to create the proper programming. Okay. So you can try for yourself as an exercise. Write the same code. You can even copy this and just modify it to calculate an approximation for sine. Okay. Now, okay, this is very easy. So math, map, and Python lists. So sa lists, you can create a list of values like this, right? We already saw this in the previous module or in the previous notebook in day 1.1. If we want to get the sum of the entries in that list, then we can use the command sum. Okay, so i-add na niya tanan from 1 to 6. We want to print out the minimum or the maximum, then we can use these different commands, min and max. Okay, so of course the minimum is 1 and the maximum is 6. So, for example, we want to get the logarithm of each element in list 1. Okay. So the traditional method using for loops, so how many lines is this? 1, 2, 3, 4, 5. Okay. What this does is it gets the natural logarithm of 1, 2, 3, 4, 5, 6 and puts it on a new kind of list. Okay? Here we call it list 2A. Okay, if we want a shorter version, we can do list comprehensions. Basically, we create a variable list 2b and then we create a list by making square brackets. And then we say the rule for members of that list. So, list 2b is kung qualified ka ani, part ka sa list 2b. So, math.log x for x in list 1. Meaning, tanan element sa list 1, paon niya ang natural logarithm, mo na siya ang list 2b. Okay? So, you get the same thing. Okay? Here, this is more conservative. Practically, this is just one line. Nag-add lang man tagsakan line in order to produce the output. Or we can also use the function map. Okay? What map does is it maps the operation. So, mo niyang operation, math.log. It maps the operation to the entire list. So if this is your topological space or this is your entire list of values na gusto nimo i-operate si log, then you can use the mapping function. It functions the same way as what we mean by maps in abstract algebra, meaning a creation of image from a domain. So it's also going to give us the same things. Okay, so basig mo gana ra na siya sa mga built-in functions na sa module. No, we can also do that with our own defined functions. For example, let's make a function called quadpow. So this will return the fourth power of whatever is the argument. Okay, and then we can operate that in list 1. This is our list 1, 1, 2, 3, 4, 5, 6. Okay, so we can just run this and it's going to give the fourth powers of every element in list 1. Okay. And quadpow is a user-defined function. When we say user-defined, kita mismo naghimo. So as you can see, list comprehensions and mapping can be convenient if we want to perform certain calculations to a very, very big data set. Kaya kung mag-for loop ka, tapos for example, kani siya, this is 1 to 1 million, mag-for loop ka, magsige pa siya dagan diri og loop. Whereas, list comprehensions, although it's still a looping, pero the interpretation will just take one line. And with mapping, it also conserves. It conserves lines of code for you, and it conserves lines of interpretation for the interpreter or the computer. Pero kung dako na kayo ang imong list of values, if you have a very, very large data set, even map and list comprehensions are going to slow down your computer. And that is actually the reason why before a lot of people still preferred C and C++ over Python. Kasi sabi nila, that's a very, very slow language when treating large arrays of values. And that's why before, they didn't want to treat graphics with Python because if you have graphics, sa computer graphics man good, every pixel is represented as a tuple. So either the tuple is RGB value, so you have a value numerical values for red, green, and blue that mixes to form the color in that pixel. So that's a very, very large nested list or a nested array. So Python is very, very slow in dealing with those things if we're just going to talk about the standalone version of Python. Fortunately, there's a fix to that, which is called Numpy. So it provides a wide range of efficient ways of creating and manipulating arrays and calculating and performing calculations that involve the data found in these arrays. Okay. So what is an array? An array is a grid of values. It's just like a list. And the things that it contains are information or raw data. For example, we have list 1. List 1 is a list. Ito siya. A list of 6 integer values. We can convert that into a NumPy array using this command. Okay. By the way, first of all, to import NumPy, so you just simply say import NumPy. Or if you want aliasing, so the very popular aliasing is import NumPy as NP. So every time you use a function sa NumPy, for example, magamit kag function ng array, you say np.array or pwede ra pod numpy.array. Okay, that's the same thing, but just to make things simpler, you don't have to type numpy all the time. You can just type np. Okay, np.array. So let's hit play. Okay, so now this creates an array of 1, 2, 3, 4, 5, 6. It looks like there's nothing really different from this and this one. But actually, this becomes a very efficient tool for calculations later on. Okay, so we can also build arrays with multiple dimensions. So for example, ito siya. If we run this, so we have a 4 by 3, a 3 by 4 matrix of values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So these arrays are called ND arrays or simply arrays. Pag 2D array, it's a 1D array of 1D arrays. So for example, kung 2D arrays lang, so kanina siya 1D array. So I have like a list of na ang elements niya kay mga lists po. Okay? If I want to make this a 3D array, so dapat diri sa sulod ang elements po ani kay array like that. Okay? Pero we're not going to do those kind of arrays. We're going to deal with matrices lang muna. By the way, if you have something like a 3D array or more, those are no longer treated as just normal matrices, but those are actually already tensors. Okay? So the rank of the tensor will be determined by the size of that tensor. So it's the same, we're talking about the same tensors that we see in differential geometry. Pero dito lang mas hindi abstract yung way of treating it. Anyway, we will discuss tensors when the time comes. But for now, let's just stick to arrays and matrices. Okay. So here we have 2 rows and 3 columns. So this is a 2 by 3 array. And then we can also access the elements of the array with brackets. For example, let's print this. So 0 meaning the first row. First row, 1 is the second element in the first row, so that's 2. Pag 1, 2, meaning that's the 1, this is the second row. And then the number 2, that's the third element of the second row, which is 6. Okay? So as an additional illustration, for example, if we want 1, 0, so we're going to get 4. Why? Because when we say 1, that is the second row, and 0, the 0 position is the first element, so that's 4. Okay. So the elements of a 2D array, so this is a 2D array, are 1D arrays. For example, if we just want, we say A0, so that is the first row. Okay. So that's this array, 1, 2, 3. Okay, so now there are 2 main ways to perform matrix multiplication in NumPy. Pwedeng dot function. So if you have defined the matrices A and B, just use the dot command or the at operator. Okay, but remember, the rules of matrix multiplication still apply. So kung hindi parehas ang row sa A, kunya ang column sa B, dapat similar. I mean, they should, there are rules that should be obeyed. So kung say rules na gina-obey sa row and column rules in matrix multiplication, that also has to be obeyed here. Okay, so we're going to get basically the same thing using the dot operator and the at operator. So how are the numpy arrays? How are the numpy arrays and the lists? How are they different? Okay, so if you have lists, for example, P list 2, 3, 5, 7, 9, and then C list 0, 4, 6, 8, 10. If I add these lists, what's going to happen is it's not the addition that we are expecting. Instead, it's going to create a new list that is composed of the elements of P list and C list. Okay? This is called concatenation. So it concatenates. Okay? So the asterisk operator, pag matrices, ang atong expectation, when we say 1, 2, 3, 4, asterisk 3, what we're expecting is 3, 6, 9, and 12. Okay? Pero if it is a list of values, it's just going to repeat that list 3 times. Okay? So pag 5, also repeats 5 times. So it's not that easy to perform calculations with lists. Because remember, lists are collection of data. But numpy arrays, they are collection of numerical data. So automatically, all of the operations are assumed to be mathematical in nature. Diri man god, na-treat siya as strings because lists are also interpretable as strings. So for ND arrays, if we use plus, it's going to result in component-wise addition. For example, we have two numpy arrays, the matrix 1, 2, 3, 4, 5, 6, and another matrix 2, 3, 4, 5, 6, 7. So if we add them together, B1 plus B2, it's now going to give 1 plus 2, which is 3, and then 2 plus 3, which is 5. Basically, component-wise addition. Okay? Now, addition or multiplication, for example, if you have this matrix or array, numpy array, and then you add a scalar number, so it's like you're multiplying this by an identity matrix of some sort, and then adding that to all of the elements of the list. For example, B1 is 1, 2, 3, 4, 1, 2, 3, and then the second column is 4, 5, 6. So it's going to add component by component the scalar 10. Okay. So multiplication also works the same way. So mamumultiply lang siya by 10. So 10, 20, 30, 40, 50, 60. Okay. And then if we multiply them like this, we get component-wise multiplication. If we want to multiply them like, normal matrix multiplication, then we will have to use either the dot function or the at operator. Okay, so there are 4 basic attributes of an array. So D type is the data type. Unlike lists and tuples na pwede nga ang elements kay lahi-lahi nga data type, sa array, it's usually just either they are all integers or they are all floats. Most of the time in numerical analysis and scientific computing, we will be dealing with floats. If you can use NumPy for number theory, in which case you will have to deal with integer data types. Now, ndim over here, is the number of axes or dimensions of the array. Okay, so for example, where is the array which we called A? So this is A. 3, negative 1, 4, 1, 5, negative 9. So its data type is integer. The dimensions are 2, meaning there are 2 axes. 2 axes, ang isa ka axis is row, ang second na axis is column. The shape is the tuple of integers indicating the size in each dimension. So for example, how many rows? The rows are 2 and the columns are 3. So the shape is 2, 3. And the total number of elements in the array, so it's just going to count how many elements here. So of course, there are 6. Okay? So we can do the same thing with B1. We defined B1 above, so we can change all of this to B1. And just press wait. Okay, so B1 is also of the same size. So B1 has 2 rows, 3 columns, and then integers din lahat. And also 2 axes, and obviously also 6 elements. Okay, so let's now go to something more important. So array creation routine. Sometimes we need to create operators. For example, operators for the Hamiltonian, and we need to assign values to the elements of a Hamiltonian. So we need to make combinations of different matrices. So if we want to create a 1D array of 5 zeros, we just need to say np.zeros 5. Okay? If we want to create a 2 by 5 matrix of integer ones, so the command is ones, and then we say it's 2 by 5. Ang shape niya dapat 2 by 5, meaning it's going to be 2 rows and 5 columns. Kung 1D array lang, pwede po ta mag np.ones, and then okay, let's say 12. Okay, so it's going to create an array of 12 12 floating point elements na 1. If we specify na the data type, by default in Numpy, it's going to treat floats because Numpy is used for numerical analysis, and by default, it's going to be dealing with non-integer time steps. So it's dealing with floats. Pero if you want to force data types, for example, you want integers, pwede rin naman. So it's going to give you something like this. But by default, it's going to give you a row vector of floats. Okay, we can create, for example, a 2 by 2 identity matrix using I as in mata. So if you want to print I, so it's going to come out something like that. If you want to create 4 by 4, say for example 4 by 4, so we just say np dot I 4 then print I4, going to create a 4 by 4 identity matrix. Okay. Okay, let's see what this does. Okay, so what happened here? Remember, I is the 2 by 2 identity matrix. When we say full like, meaning, lahat ng laman niya, papalitan mo ng 3. Okay? So that's how you create something na composed of similar items. So for example, if you want to change the data type to one of Numpy's float types, so it becomes, so for example, originally you are reading data that are integers and you want to convert this to float. So you just use ASE type and then put np dot For example, kung float 64. So what this means lang kung float 64 is, it's a floating number with a 64-bit precision. Again, if you want to know more about precisions, go back to these references. So you can also put float 32, so that's a floating point number with a 32-bit precision. Okay, so more functions. We can create, for example, let's have a NumPy array and call it A1. So A1 is a matrix. It's a 3 by 3 matrix. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we create a diagonal or construct a diagonal array. So we want to find the diagonal. So muna ang diagonal ni A1, 1, 5, 9. Okay. We want to triangulate. So we get, well, it's not really the triangulate that you would usually have in linear algebra, but basically it converts the other values here into a zero. So you have something like this. Okay, so this is lower triangular portion. Okay, pag TRIU, so tri-U. Pag tri-L, so this is upper triangular, ang mawala kay ining top 3 triangular elements. So in this case, mo ni siya ang nawala. Okay, these are not linear algebra nga triangulation ha. These are creation. So you're creating an array. For example, given this array, create an array that looks like this. So you just use np.trill. Okay. So even if you don't have an existing array ng 3 by 3, you can always use diagonal to create a diagonal array. For example, the Minkowski metric, that's usually just -1, 1, 1, 1. So you can get that by simply saying np.diag -1, meaning mo ni siya ang himuon ni mga values sa diagonal. And if it's a diagonal matrix, meaning all the other elements are 0. Okay, so these are the different ways of creating matrices. I mean, creating NumPy arrays. Now let's go to how to access these data arrays. Okay, so let's say I have data. A range, pag sinabi nating A range, so it's going to give values starting from 1 up to before 100 at intervals of 2. Okay, so it's going to give us integer values kung A range. Okay, initial point, end point, and interval. So that's when you say numpy.arange. Something more useful in numerical analysis is what we call a linked space. So you have an initial point and then a last point, so 1 and 10. So what's this third argument, 20? So this is the number of points. So what this does is, it creates a NumPy array of 20 points that are equally spaced between 1 and, I said 100 here, this is supposed to be 10. Between 1 and 10, okay? So if we run this, it's going to create that, 20 values between 1 and 10 that are equally spaced. Okay? Kung gawin natin yung 100, okay, this is going to be really bad. Okay, so it's going to give you something like this. For example, I want to increase that. So now, yeah, so I get a really large set. So these are 200 points between 1 and 100 that are equally spaced. Okay, for brevity, let's just stick with 10. Okay, so how can we access the elements of a NumPy array? So we can use the same slicing syntax that we used for strings and lists. For example, if we say data1 4, asan ba si data1? This is data1. If we say data1 4, so you get the fifth element because this is 0, 1, 2, 3, 4. Aha. So you get 9. Okay, if we say colon 3, so So that's going to start from the beginning up to before the third or the second. So it's going to give you, I mean, yeah, up to the 3 plus 1, up to before the fourth. So 1, 3, 5. Okay, if you say data 1 minus 3, okay, it's going to give us the last three elements, 95, 97, 99. You say data 1, 528. So start from position 5. Position 5, so 0, 1, 2, 3, 4, 5. So that's 11. Up until before the 29th element. Okay, so we get something like this. What's the shape of data 1? Uh, so we get now 50. So, okay. So, are there questions? No. So for example, let's go back to the example of the Minikawa schematic. Let's just stick with this example since it's a very, very easy matrix. We only have all one values, well, except the other one is -1. So if we want to access the element at the nth row and nth column, so it's just like assigning indices to matrix components. For example, 0, 0, we're going to get -1 because this is 0 first row and first position. 1, 1, we're going to get 1. We say 1, 3, so that's in the second row, fourth position, 0, 1, 2, 3, so that's 0. Okay, let's see here. So all of the rows from column 2 and onwards. So lahat ng mga rows, pero ang igawas lang nato kay ang column 2. So 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, and 0, 1. And if we access -1, obviously kung unsa pinakatumuy nga element, kung ano yung dulong element, it's going to give you -1. And if you say -1, -1, so in the last row, what's the last element? Which is also 1. If we change this to -2, this is going to be 0, meaning in the last row, what's the second to the last element? So array manipulation, just because we set an array to a particular shape doesn't mean to say it has to be always that shape. So for example, if we have a 1D array, so natay array no nga 0 to 11. So this is a 1D array, so isa ra siya ka row. We want to reshape it into the shape 3, 4. When we say 3, 4, 3 rows, 4 columns. So we use the reshape command and it gives us a reshaping. So 3 rows, 4 columns. Okay, so when we say 2, -1, it just means to say basta kay 2 rows and the appropriate number of columns. So pag 2 rows, dapat 1, 2, 3, 4, 5, 6. Dapat 6 columns. If we say 2, 7, we want 2 rows with 7 columns. Let's see what happens. It should throw an error. You cannot reshape it because you are limited by the number of elements. You also cannot put 5. Okay, it's going to give an error, or it's going to throw an error. So the right one is 6. Just in case the array is too large that you don't know how much columns there's supposed to be, just put -1. And it's just the same as saying, I want 2 rows, ikaw na bahala sa columns, basta dapat tama. So the computer will take care of it for you. So for example, if we have now a new array, which is this one, and we shape it to 3, 4, then that's 3 rows again, 4 columns. Okay, let's see what the function ravel does to A1. Okay, when we ravel, that means you flatten a multi-dimensional array to a 1D array. Okay? That means bisag unsa pay shape ani, bisag pila pa na siya ka number of rows and columns, if I'm going to put it inside numpy.ravel, it's going to revert that back into a one-dimensional array or a row vector. Okay. So A1 dot transpose. So remember, if you're transposing if you have a 3 by 4, then this now becomes a 4 by 3. Okay. Same rules as in linear algebra applies. And if we now transpose this one also, where is A1? So yeah, I mean, this works the same way as A1.t dot t and numpy.transpose works the same way. Okay. Now, for example, I want a tran 2 dot t. Okay. So it's going to revert it back to the other form. Okay. So if you transpose a transpose, you're going to go back to the original matrix. Okay. So that's very broadcasting. So broadcasting is a way of automatically performing a series of operations to all the elements of an array. So let's make a new array. For example, if our new array, we define our new array as A3 and X1. So let's just display A3 first. So A3 is from 0 to 11 kasi that's A range 12. And the shape is 4 rows, 3 columns. X1 naman is just 3 values. So that's from 0 to up to before 3, so 0, 1, 2. If we want to add the entries of X1 to the corresponding columns of A3, so we just say A3 plus X1. Okay, so what happens is this one is added to 0 is added to each of the items in the first column. 1 is added to each of the items in the second column, and 2 is added to each of the items in the third column. Now, for example, we have a range of numbers between 0 and 40. Now, ang distance nila kay 10, so that's 0, 10, 20, 30. So this is in a shape of 4 by 1. Normally, man good, if we remove this, so this is going to give us a row vector. Okay, if we want a column vector, then we say shape. Then here we put 4, 1. Okay, so this produces, instead of a row vector, a column vector. Okay, if we want to add y to A3, so now y is a column vector, so the corresponding addition will be to the rows. For example, A3 is this one. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So in the first row, it's going to add 0. So wala natarog ang first row. And then it's going to add 10 to the second row, 20 to the third row, and 40 to the fifth row, to the fourth row. Okay. Then we can also add X1 and Y1 together with array broadcasting. So meaning we have X1, which is originally the row vector, and then we get something like this. Okay, so far we have discussed how to create arrays, how to perform component by component operations, and how to perform uh, operations to entire rows or to entire columns, and also to reshape reshape our data. Okay, so the exercises here, I'm not going to go over all of it. So here you write a function that defines the following matrices as numpy arrays. Okay, so this is C and this is S. How do you create this one? How do you create this? Okay, so the hint here, so I need to put hint. So hint for creating C is use np.ice. You could also use, what else? np.full like. Ano? Simpler is np.once. Okay? So you can make np.once, and then pag nana kay matrix of all ones, then you can uh, create a lower triangle by np.trail, lower triangular. Okay? And by a similar combination of operations, you can also use C. Okay? Then once you have once you have created C, you can just use, so U will be equal to C dot E. Okay? So, meaning lang, because U is the transpose of C. So when you are successful in creating this numpy array na, ang button lang ninyo is transpose by using .t, or pwede po np transpose. Okay, so let's go to row stochastic matrices. Okay, so for row stochastic matrices, think of any matrix, pero dapat ang kada row niya, kung i-add mo ang elements of the row, the sum should be equal to 1. Okay, this is an important tool for calculations involving density matrices. So write a function that accepts a matrix and creates a row stochastic matrix. Okay. You can do this. What's a hint? A hint I could give you. The hint here is broadcasting, because in order to create a row stochastic matrix, for example kani siya, kung gusto nato ni himo og row stochastic matrix, unsa may sum aning nga row? -1, so this is 20 minus 1, 19. So dapat lang kanita nang nga row, using array broadcasting, i-divide na ko siya by 19. Para ang sum nila, pag akong i-total, is equal to 1. Okay? So that's how you make row stochastic matrices. And okay, here's something that I really want to discuss. Although we will talk about easier ways of doing this with ASE. So the Madelung constant, it gives the electric potential in an atom felt by an atom, particular solid. So for any atom, let's say ang atom nga gusto nato i-check is the atom positioned at the origin. So if IJK are the coordinates of the other atoms in that solid, so the contribution to the potential felt at O is this. Well, this is just from basic electromagnetism. If we total all of the potentials, the net potential felt by atom O due to all of the atoms in that solid, then we're going to get something called the Madelung constant. Okay? That means when we let L approach infinity. Okay, but of course, as I said earlier, hindi naman marunong mag-interpret ng infinity ang computer. So you will have to keep on testing by substituting here a really, really large value. Okay? If the value still changes, hindi pa nag-converge, then you haven't reached the Madelung constant for sodium chloride yet. Okay? One thing that you'll have to be careful lang is if you perform a loop, dili dapat appeal ang origin 000 because you're going to get division by 0. Pero it shouldn't be included anyway since at 0, that's atom O. So we want the potential felt by atom O. So dili na to i-appeal si atom O. Okay? So you will be able to write the potential into something like this, and then M is going to be the Madelung constant. How to know if it has converged? Okay, refer back to this where is it? Okay, refer back to this code. Okay, in this code we showed how we can check discrepancies between a certain value and the value of a particular approximation. Okay, so that's one way of checking for convergence. So you keep on testing. Start mo siguro L equals 100, and then try changing to L equals 101. If the result is different, then you have to try a larger value for L. Okay. This one is optional even for Ma'am Jessa's advices. Kasi this is not naman. This is not solid state physics. But basically, this is the semi-empirical mass formula. How do you calculate the binding energy of an atomic nucleus given the atomic number and the mass number? Okay. This is a bit complicated of a programming task because you are going to branch 3 times. Okay? If A is odd, if A, Z are both even, and if A is even and Z is odd. Okay. I don't assume that anyone will be able to do this right away, but this is not a difficult problem. It just takes a lot of lines of code. So the first task is to write a program that runs from A equals Z to A equals 3Z, and then calculates B over A. Okay? And the one with the largest binding energy per nucleon, that's how you find the most stable. Wait, this shouldn't be nucleus, this should be isotope. So that's the most stable isotope for that particular element. Okay? And then you can modify the program so that you take values of Z from 1 to 100, meaning you are going through the first 100 elements of the periodic table, and then print the most stable isotope for each one. Okay? It's a big programming task, but if you're willing to do it, you're going to learn a lot in how to create proper branches. Okay? Again, don't worry too much with the exercises. The exercises are meant so that you will always communicate with me, especially yung mga advices ni Ma'am Jessa, or anyone wanting to do the exercise, so that even if it's not Saturday, we can always communicate. Also, it makes me sharper if I can explain these concepts on a daily basis. And also, since namimiss ko na rin mag-physics. And also, most especially to the students who will be benefiting from the atomic simulation environment, this prepares them for more of the sophisticated tasks that will be done in future sessions. Okay, so this is the second notebook. So you want to take a break, or the last notebook is very, very quick kasi it's just plotting. So do we take a break or is it okay with you na I'll go straight to the third notebook? Okay, silence means yes. Uh, I'm going to go through the 1.3 now. So again, if you have questions, you just throw the questions in sa Google Colab. And I'll try to browse every now and then sa chat to see if you have questions. Okay, so we're now in the third notebook. This is really, really quick. Anyway, assuming that you were able to perform your calculations, that means you already have a set of data. So how do you plot that data? Okay. So you plot that data using visualization libraries. The most common visualization library, or the most popular or the simplest, is what is known as Matplotlib. So Matplotlib is a very, very big library. So usually pag nag-i-import tayo, we only import certain sections of it. So for now, I'm going to use just pyplot and import it as with the alias PLT. If you click this in your notebook and you're connected to the internet, it's going to bring you to the website for Matplotlib, and they have tutorials for almost any kind of plotting that you will need. So I'm not going to make this a very, very detailed tutorial on Matplotlib because basically, ano lang naman to, visualization. So you can visualize data by, for example, if I have two sets of data, X and Y, and I want to visualize it on a plot. So the first argument will be the horizontal axis, and the second argument is going to be the vertical. So if I run that, which I have already run, it's going to turn out, oh wait, it's going to give an error because I forgot to run this first. Remember, you should always run the preceding cells. Okay? So, ito lang yung one of the things na makes Jupyter notebooks very difficult to use sometimes because if you forgot to run a particular cell, baka hindi gumana yung mga next cells. So, for example, we made the alias PLT pero we didn't run the import command. It was not able to identify what PLT is. But now that I did, it's going to run the PLT. Wait, so there's a question in Telegram. Dapat palindrome. Okay. I'll just copy this part. Okay, so here in Jupyter, kailangan naka-inline, meaning in each coding cell, dapat naka-inline ang ang matplotlib. Okay, so you're always telling the cell to don't forget about matplotlib. Okay, so this is just an additional command. You don't have to do this if you're doing in Spider, but if you're doing it in Jupyter or in Google Colab, so we have to run it like this. At every line, kailangan nakandyan siya. Okay, so we can also have a very, very detailed horizontal data set. For example, ito. So, 300 equally spaced points between negative 20 and 20. And then we have uh, y1 equals x1 squared plus 1, meaning for each data point in x1, you square it and you add 1, that's going to be the vertical axis. Of course, this is a quadratic function, so it's going to turn out something like this. Okay, so you can also display 2 or more functions in one plot. So here, we're plotting z squared plus 1 and z cubed. Ito yung z values and ang vertical ay y values. So we just say plt.plot and this one. So this will be for z cubed. Now these arguments, these will represent what kind of markers do you want. Okay, when you say k is black tapos 0. Okay, so that's why this one is black and bilog or circular markers, KO. If you want, for example, the second function, the y equals z cubed, R means red and the asterisk means star. Okay, and if you want to generate labels, so you just put label equals quadratic and the other is label equals cubic. Whatever word you put here, that's what's going to come out in the legend. Okay, chart title, this is self-explanatory, and so are the labels for the plot. So plot.x label, so it's going to label the horizontal axis, and plot.y label, it's going to label the vertical axis. Okay, so legend, loc equals 2 means this is a number pertaining to a location in the chart. So loc equals 2 means it's situated in the upper left corner. If I change this, for example, to 0, let's see what happens. Nothing. If I say 3, okay, it's going to change the location of the legend. Okay. So I put some comments here so that you'd be able to understand what these particular commands mean. I forgot. So label equals, put label here. It's going to come out as something like this. Okay. Now we can customize it by adding xlim and ylim and grid. So pag x limit and y limit, it's going to increase or decrease the visible part of the plot. Okay. Grid, of course, it's going to create the grid. Okay. So if I remove x limit and y limit, what Python is going to do is going to give you something near the center or where most of the values of both plots are located. Okay. If we put this in, so we can specify just what portion of the graph we want to show. For example, gusto natin ano lang, dito lang, 0, 6. So we can change this value here to 0, 6. Okay? So these are just ano naman, viewing commands. Okay. So if you have raw data, okay, we can use the load text. So if you're doing this in locally, when you say locally meaning sa Jupyter notebook in your computer, then you can simply use load text. Load text is a Numpy function that loads not just text files, pero bisag Excel, bisag CSV files, any type of files as long as it's raw data. So it's going to load uh, the name of that file. Okay? An important thing to note lang, diri sa Jupyter, is if you're going to load raw data, you have to make sure that you know specifically where that data is located. For example, I said np.loadText stars.txt. Okay? That's because the stars.txt is located on the same folder. Okay? So, if you're going to do it in Google Colab, then in Google Colab, there's something else that you need to do first. Okay, you need to upload the file. So from Google, you can follow along if you're doing this in Google Colab. From Google, import files, and then run upload equals files dot upload. So let's see what happens here. Okay, so it tells us to choose a file to upload. Then we just have to look for it. For example, if I want stars, dot text. So it's now uploading stars.txt to the directory in the cloud computer that you are currently using. Okay, so what if, for example, you're doing this on Jupyter? So in Jupyter, if for example wala siya sa the same folder, it's located in some other folder. So dito, let me escape this. You will have to put here folder slash stars.txt wherever the address is. Okay. So a good trick to do that is, for example, you know where it is located in your computer. So you just press right click, properties, and you can see here the location. Okay. For example, if this is the location, so I'm going to type all of that here, slash stars.txt, and then it's going to load this data. Okay. So how did I load this data? So if we open stars.txt, so this is stars.txt. It's really just an ugly catalog. So this is a catalog of temperature and brightness values for stars in our galaxy or nearby stars. So this is a project we did before with AstroPi. So we load that data. First, we need to load X values and Y values. Okay, we can open this in an Excel file to see which is the X values and the Y values. But you don't really need that if you're going to do things in Python, because it's going to identify it right away using index slicing. So pag index slicing, the X value is usually positioned at the first row. So 0 and then 1. Okay? Pwede nyo itong pagpalitin, pero if you reverse this, so of course, ang imong plot, mabaliktad po siya. Pero basically, you're visualizing the same data. Okay? And labeling, title, grid, those are fairly standard. Okay, so in your content folder, there is another, this is a very, very large data set. Sunspots. So NASA counts almost every month. They count how many sunspots have been observed since 1749. So there's a very, very big collection of data on this. And you can plot the data using the same commands. Okay? Bailuan lang ninyo ni diri with sunspots.txt. Now the challenge is to go over this data and do this running computation. So this is a running average, meaning every after 5 months, you compute a running average of how many sunspots are there. Okay, and you make two plots. The first plot is let's do the first plot. Let's just copy this here. Let's put sunspots data equals I'm not going to show the entire solution, but just as a guide, this is how you plot the data from this text file. Wait lang. Sorry. Nope. Sunspots data. Okay, so what happens, by the way, in load text is it converts the entire thing here, whatever is contained there. That's a very, very big set of values. This is more neat. Mas neat ni sila nga values. So it's going to collect all of that and form a NumPy array. So it's going to be a 2D NumPy array, and you can access the corresponding 1D arrays by index slicing. And so you get something like this. Let's make this red. So red and 0, meaning circular dots. So it's going to come out something like that. Okay. So this is the data for the counted sunspots from month 0, whatever month 0 was. So month 0 was, I think, January 1749 up until some value. Okay, so contour and density plots. So sometimes we have a 3-dimensional function, but it takes too long to analyze it by plotting 3D models. Okay? Sometimes what we need are only visualizations at 2-dimensional grids of data. Okay? So for example, there's an example here which takes values from a scanning tunneling microscope. Later on, we will have that. Pero in condensed matter physics, for example, if you have graphene and you want to measure the changes to charge density across that entire sample of graphene, you're not going to make a 3D model. You're going to create contour plots. So to create contour plots, you need to form what are called as mesh grids. So for example, we have 2 sets of 1-dimensional NumPy arrays. So ang isa ang tawag is X values, the other one is Y values. Okay. We can create a mesh grid using those values and assign capital X and capital Y. So ang markers na is dot, color is black, and line style para dili sila mag-connect. So it's going to create something like this. Meaning, this will be the entire sample size of our data. Okay, so for example, if our measurement is a function, z of xy equals sine of quantity squared x squared plus y squared over x squared plus y squared, we're going to sample that data based on these points lang. Okay? So kung may mga points in between, we're not going to calculate for those points. Okay, just going to sample and compare the values between neighboring sets of data. We do that using contour plots, and when we get contour plots, we get something like this, which is something that must be familiar na. So, terrain plots, topological maps, yan ang mga usually ginabuhat sa mga genetic engineers. So, those use contour plots. And we can color that. Sometimes it's very hard to read contour plots if you don't know how to read it. So, a more efficient way of reading it is by employing color bars. Okay? So, we can give it a color map. So when we say RDGY, that means red to gray. Red is the smallest and gray is the largest value. And then we put the command plt.colorbar. So what color bar means is it's going to give a legend of showing how the values change depending on the change in color. Okay? So if we run that, we get something like this. So the smallest values are somewhere here at the red, and the largest values, black, is somewhere near the origin, near 0, 0. And that's normal because as the values of x and y get smaller, so the divisor gets really, really small, and the value of this function gets infinitely large. But at points that are very, very far away from the origin, there's going to be fluctuations or periodic changes in high and lows, but basically, these are low valued na. Okay? That's because as you move far from the origin, as this gets larger, then the values will get smaller. But because sine is a periodic function, so every now and then, there's going to be an increase and a decrease in the value of the function. Okay. So color maps are also useful in calculating the concentration of heat or charge density in a two-dimensional material. For example, in semiconductors. So if you want to know asa nga part sa semiconductor ang niinit, and you have a data, measured data, you can use color density plots or contour plots to find which points have the highest and the lowest heat points, or kung charges, the highest and the lowest charge densities. Okay, so there's also another file, circular.txt. I forgot what this is about, but this is a measurement of, I think, wave ripples. So another way of, if you already have raw data and you want to create a 2D image of it, then you can just use imshow. So imshow is will sample the image on a 2D raster, very, very much similar to this, pero it's a default 2D raster by Numpy, and it's going to give you the changes in the values of the wave across the ripples. Okay, so this is just the normal way of loading text into Jupyter. Imshow, so directly you show the values as sampled on a 2D raster, and then color bar, paano lang ng color bar, that's just a guide of the rise and fall of the values. Okay, so here I printed the horizontal and vertical portions of the data circ. Okay, so that you can imagine look at the values here and then compare it with the color, so that you will see kung paano sinasample yung raster data. Okay. So basically simple lang man siya. Just load the raw data into a variable, and then you use imshow to visualize the data contained in that variable. Okay, here's a really cool example. So a scanning tunneling microscope, if you are students, you might it might be helpful that you look this up. So this is a way of measuring, of identifying the terrain of a surface. For example, in solid state physics, ang surface sa isa ka object, you can determine it by tracking a sharp tip. And that sharp tip will produce a quantum tunneling current. And then those current values are recorded as the coordinates of the tip changes. Then at the end of the entire characterization, you're going to get a 2D grid of values that will represent the height of the surface. So this is located in the file stm.text. So did I include it here? Yeah, it's in your folder. So you get a value like this. You're going to go through all of that. Those are a lot of values. And then write a program that reads the file and makes a density plot of the values. Okay, so I'm going to make a very simple example of this. Let's say heights. STM heights equals numpy.load text, and I will load the text titled called stm.txt. Okay, that's really the name of the file. And then what's next? You just say plt.imshow stm heights, and then also we use the color bar, or and then we give it the command to show. Always include this, otherwise dili na siya i-show sa Python. Okay, so there are different color maps. So gayon na nakita na to ang RDGY na color map, and you can use plt.hot, plt.gray, plt.jet para ma-represent ni siya. Basically, ang color map scheme lang ang gigamit dito. So this is jet, and then there's a gray, which is just a grayscale. So we're going to use the grayscale here because SEM scanning electron microscope images are grayscale images. Basically, almost all microscopic images are grayscale images. So let's put plt.gray. We want the color mapping here to be gray, and then let's put the color bar. Then finally, let's show the figure. Let's see if this works. Okay. So we get something like this. So this is the, you might be shocked kasi nga na di ang surface sa silicon. This is the 111 slab. I haven't discussed solid state yet with Jess's advices. But basically, if it's a 111 slab, think of a normal bulk cube of silicon, and then siyang i-chop diagonally. So that's the 111 slab. And then you measure and then you characterize that surface, 111 surface of silicon. So this is how you get that data. You can just try playing with this to improve the resolution, but I don't think we can improve the resolution further because maybe it's limited by the amount of data points in STM file. Okay, so that's the end of the third notebook. That's the last notebook for this day. So for the task, again is required para lang sa sa students ni ma'am. So are there any questions? Accessible. Okay, I'll deal with those points later. Okay, so let's go to the task, because this task is very much connected now with molecular dynamics. It's not molecular dynamics yet, but it's close enough. So first, I'm not going to read through all of this. since instead of just describing the what's supposed to happen, I drew something. So I hope you can see this here. And come to think of it, I should have just loaded. Well, I don't know where I do this now. Anyway, so for example, you have particles in a box. Okay? Initially, lahat ng particles mo are on one side. Okay? Now, for each ball, for example, if you can see this, for each ball, for example, for this ball, assign a random number between 0 and 1. Okay? That will represent the probability of the ball to move to the right. Okay? So we're not giving it physics rules, just straight out probability. So randomly, we're going to give it a random number between 0 and 1. And then, for example, if there are a total of, how many are these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If there are a total of 12 balls here, for example, if there are 12 balls and 10 balls are here and 2 balls are at the right, so the quantity n over capital N will be 10 divided by 12. Okay. So kung ang assigned na random number for this ball is smaller than this number, for example, in that case, smaller than 10 over 12, then we can make a rule na it's going to cross to the other partition. If not, it's going to stay there. Okay? And then after we do that, we increase the time step from t equals 0 to t equals 0 plus delta t. So for example, kung ang delta t kay 0.5,
Jolo.
PM siguro siya. Is mabalik na. So si Palomo o si Pedrijo, tas-tas gud ang imong braso no. Nag-burn out
At
siguro.
ma'am, nag-burn out man daw siyudad, ma'am. Ingon si Ria.
Mao lagi. Sige, so,
Nawala si nag-record man sad ko.
okay, okay. So, kung ano siguro, o manang pag siguro siya, mo na siguro to. So, ato ang next na lesson, magpadayon ta the same time sa next week, Saturday. Yeah, about sa inyong assignment, si diretso ra mo kang kuan, idolo og submit.
Yes,
Ha?
ma'am.
Tapos, mm, kanang, okay naman siguro tanong, naata evaluation, isend na lang siguro kang kuan, kang general sa, ang katong evaluation, o katong sa uban nga naka-appeal, sa atong evaluation, okay na na sa yoy, maka-access na niya. Ito madungog sa iyo. I-try natin. So, murag di naman itong balik si Jolo. So, salamat kaay sa tanan. Mariel, na-record mo po din mo yun daw. So, here ends our first day activity. See you on the next day. Available ng evaluation form. Just click the link. That's that one. Thank you, everyone.
Thank you.
Bye.
Thank you, ma'am.
Salamat.
Bye.
Bye,
Thank you,
ma'am.
ma'am. Bye.